Hello guys, and welcome to yet another video. And this time we're going to try and figure out how this paper must have gone for those who wrote it. By the way, Happy New Year's. Is it Happy New Year's? No, it's Happy New Year. Alright, I hope you guys have had a good time and you've had your holidays in the most exhilarating way possible. Otherwise, it's time now to face a bit of reality and try and figure out what you guys are up against for the year 2023. And of course, that is for the new matriculants. So this will give you an almost overall type of look into your curriculum for this year. But if you are a matriculant who wrote this paper last year, this can help you to gauge how much you scored on this paper. Okay guys, let's just not waste too much time and get to this one. So this is the paper 1 of maths that was written in 2022 November for the finals. Alright, we're just going to scroll down into the questions. But the most important here, I know all other, instructions are important, but I will pay particular respect to this one. It says show all calculations. It can be calculations, it can be a diagram, it can be a graph, but I like this part, the etc. A lot of people don't pay attention to this part. It means absolutely anything that maths allows to be used. So you need to show what you have used, okay? So you're not only limited to a particular way of solving these things. Otherwise, you have to know and familiarize yourselves with this. You have to familiarize yourselves with this one. And it says round off, maybe this one, round off to 2 decimal places. Okay, so 2 decimal places. Remember, at times they would say at least, but you see here they're not saying at least. So do not be found rounding off to say 3 or more. It says 2 unless otherwise stated. So please guys, make sure these things are in order. Okay, let's get to question 1. Of course, question 1 is basically basic algebra, isn't it? So we're dealing with algebra here. Now, how are we asked this question? So 1.1 is always dealing with quadratics, and in fact the entire question 1, it's usually quadratics, but question 1.1, it's mainly quadratics, but they come in different forms. First, you get the standard quadratic that you deal with in grade 11. I see now you guys are also doing it in grade 10. But this one you can easily factorize to solve. You can complete a square to solve. You can use the general quadratic formula to solve. The second one, it has irrational roots, so you only have 2 options there. Solving by completing a square, or essentially using the general quadratic formula. And then you have a quadratic inequality, which again you have tools that you can use to solve that. Then it can come as a quadratic insert form. Okay, so again you will solve as you know how to solve a quadratic, but there are certain strict points that you have to make sure you reconcile when you're solving these. And then of course we get simultaneous equations, which are essentially going to involve some kind of a quadratic expression as well. Then you solve as you would a quadratic equation. And then you can get a few flavors where you get a bit of logs or exponential expressions, and then also an exponential equation. And then at times they will throw in some nature of the roots type of question, but you already know what to do. Okay, let's start with 1.1.1. Okay, 1, but I think that space is quite large, so let's start here. So we have 1.1.1. Given to us is 3x minus 6 into x plus 2 is equal to 0. So make sure you copy things correctly. There's no room for errors here. So we can already make a conclusion here and say x is going to be equal to 3 because we transpose 6 and divide by 3, so it's actually going to be 2. Okay, or x is equal to minus 2. This is simple because it was already factorized. And then of course you double check by taking this back into the original expression. If you put a 2 here, you get 6. 6 minus 6 is 0. So 0 multiplied by any value that is here is effectively going to be 0. So this is correct. And then you look at putting a minus 2 there, you get minus 2 plus 2, which gives us a 0. 0 multiplied by any value that comes out here will effectively be 0. So you know that those two values are correct. And those are essentially the 2 marks offered. So 1.1.2. Okay, let's see. This is 2x squared minus 6x plus 1. So this is 2x squared minus 6x plus 1 is equal to 0. So again, when you are copying, make sure things are copied correctly. And then the instruction is we're solving to 2 decimal places. So what we do here, we just use our general quadratic formula, which solves our pain. Of course, know this by heart, guys. Don't rely on to just keep running back and forth into the information sheet. It doesn't really help a lot. So we have here a 2, we have a minus 6, we have a plus 1. So what is the significance of these things? Of course, we know that this is A, this is B, that is C, okay? So we substitute the values according to the equation. So it's going to be minus into minus 6 plus or minus the square root minus 6 squared minus 4 into 2 into 1. And make sure your square root sign covers everything underneath it, or there will be a few errors in your calculations should you not do as you're supposed to do. So that's what we've got here. And then of course, guys, make a habit of trying to clean this up. I'm not going to do it. I'm not interested in that. So this is minus 6 squared minus 4 into 2 into 1 all over 4 basically. So what I'm getting here is that x is equal to 2,82, or x is equal to, and then of course with your fancy calculators you simply just change the sign where it is necessary and you solve again. So I'm getting here 0,18, okay, to 2 decimal places we were instructed. So they can say to 3 in the local instructions, so don't be stiff. The local instructions take precedence over the general instructions. Okay, it's like when you're driving on the road, there are rules of the road, but when a traffic officer directs you otherwise, you follow the traffic officer instead of the general rules in the book. All right, not a problem. Again, the other thing you want to do here is to substitute this back into the original equation and see if you're getting a number that is rounded to the nearest integer as 0. Okay, then let's do it. And then if you put this one there, you're going to have 2 into 2,82 squared minus 6 into 2,82 plus 1. The answer that we are getting there is essentially 0. So that's very good because it means the left hand side is effectively balanced with the right hand side. So this value is correct. And then of course, if this one is correct, you should get the same answer that you get when you replaced x with 2,82, and it is the case. So those are the answers, and then of course you get for the correct substitution. So you get your 3 marks there. Let's keep moving. Okay, what we have is that inequality x squared minus 90 is greater than x. So this is 1.1.3. So we've got x squared minus 90 is greater than x. Okay, so we work it out. So we're going to have x squared minus x minus 90 is greater than 0, isn't it? So now we have our quadratic in standard form. We can actually factorize it. Most likely we will succeed. So we will have x and x factors of minus 90. That can give us minus 1. You can say it's a plus 9 here and minus 10, isn't it? Yes, and then now this gives us our critical values, and then we can put them into our algebraic table, or we can just say arithmetic table, or just the table. I don't know how you guys view this. Okay, so you always here put your critical values where you would expect them. So this becomes minus 9, this becomes 10, isn't it? When you solve for x there. So you place them in ascending order from left to right. Okay, so now we ask ourselves, this binomial factor, for which values of x will we get 0? So start with the zeros. It's very easy. When x is minus 9, we get 0 in this factor. What happens when we put a value between minus 9 and 10? You can place 0, for example. You get a plus 9, so the answer is positive. So what we're interested in is the signs, not the actual values. Then when we put a 10 there, we still get a positive answer. When we get a number more than 10, we still get a positive. So if you have 0 and the positives on one side, the other side is negative. But just double check to make sure that you aren't making an error. Then when will this next binomial factor give us a 0? When x is 10. So when we put a number greater than 10 there, we get a positive answer. When we put a number between minus 9 and 10, which is simply 0, you're only left with minus 10, so to speak. So it's negative, and it will be negative here, and it will be negative there. And then of course here we're doing the product, which is these brackets. Okay, they're multiplying each other. Now we say negative multiplied by negative is a positive, 0 multiplied by negative is 0, positive multiplied by negative is a negative, positive multiplied by 0 is 0, positive multiplied by positive is a positive. And then you ask yourself, now when is this product? Because this is the critical step that interprets our question. Now you ask, is this product positive at zeros? No, 0 is neither positive nor negative, and it's not included. So what we want is the solution going in that direction, and from here going in that direction. Note that I've used open circles because the zeros are not included. Okay, so that is the answer we are trying to establish. So let's solve this thing. We can say therefore x must be less than minus 9, or x must be greater than 10. That's how you can answer it. And then of course you get a mark for the two values. Usually you get a mark for a tool that you used. So you can use just a simple number line instead of this complex table. And you normally would get marks for factorizing this thing, because the most important thing is to factorize so that you can have your critical values, and the critical values are essentially the roots of this parabola. So the roots give you the characteristics of that parabola much more clearly. Of course, you can have an option of writing that x is an element of negative infinity going into minus 9. Round brackets, union, you can say 10 going to positive infinity, round brackets. Why? Because infinity is not included, and those 10s and the 9s are not included, so that's why we're using round brackets. The most important thing here is to note that you only use the interval notation when x is an element of real numbers. If it is not the case, please do not try to do that at home. You will break your neck. So how many marks are we scoring here? Yes, we were scoring 4 marks, so that's good. Okay guys, this is great stuff. So I've copied 1.1.4 here already. So let's solve this one. So the first thing you want to do is to isolate the z, so we can transfer it to the right hand side and also transpose our minus 12 to the left hand side. So we can say this implies that x plus 12 is equal to 7 root x. Okay. Now in this instance, we have our lovely option of doing inverse operations. So to remove a square root sign, we have to square. But what you do on the one side, you must do on the other side as well. Alright? So this implies that we can FOIL now this thing out. It's going to be x squared plus 24x plus 144 is equal to 49x. Okay? That's what we're going to have, which also implies we transpose this to this side. It's going to be x squared minus 49x plus 24x is minus 25x plus 144 is equal to 0. Now that we have our quadratic in standard form, we can actually factorize it. Most likely we will win, but if we didn't win, we will have to use our general quadratic formula. So we have x, so factors of 144, that can give us a minus 25. We already know that these two brackets are negative when the last term is positive. So let's see. Now you would be wondering, what are you going to do with this big number? Very simple. You press 144 and then you make an equal sign. And then the next thing you're going to press shift. So first of all, you write 144 equals sign. It gives you 144, right? Then the next step, you press shift. And then the next one, you press the button written fact. It is effectively shown like that, sort of like a degree sign and then these colons, something like that. So you look for that button. So once you have your 144 on the other side of the equal sign, you press shift fact, and then it will give you an answer like this: 2 to exponent 4 times 3 squared. Okay, now you look at this. I mean, you can manipulate this if you understand exponents until it gives you what you want. But this one is already 16 and 9, and 16 plus 9 gives us 25. So this basically has to be minus 9 here and then minus 16 here. Okay, so a bit of understanding of your basic math helps you a lot. And then we can say, therefore, x is equal to 9 or x is equal to 16. Now, what must you do here? You test these values into the original, okay? Not here, but in the original. First of all, you test whether the left-hand side is equal to the right-hand side. Secondly, you make sure that there will be no negative under the square root sign. And you can see these values are both positive, so it's not a complex thing there. So it's already saying there's going to be no negative under the square root sign. Now, square root of 9 is 3, right? 3 times 7 is 21. So 9 minus 21 is minus 12. So minus 12 is equal to minus 12. So the left-hand side is equal to the right-hand side. Put a 16 there, it's a 4. square root of 16 is 4. 4 times 7 is 28. Then 16 minus 28 is also minus 12. So it's one of those rare instances where both values are correct. Okay, so now where do you get the rest of the marks? Of course, inverse operations. And essentially, I don't know, this factorization literally gives us these answers, so I'm not sure, but we didn't have a nice quadratic, so probably the other mark is over there. So we get that. How many marks are we getting here? 4, sorry. So we already have 3 marks. Then I guess we get a mark for those factors then. I don't know. Or maybe the rearrangement here. Doesn't really matter. You have your 4 marks in the bag. Alright. You may hear a bit of few noises. My chair is moving because I move around a lot. So please do not be be distracted by those little bit of noises. Then here we're doing simultaneous equations. What do you do here? You just sort this out and solve for y. Y is going to be equal to 2x minus 2. You make this one equation 1, and then you can make this one equation 2. So I'm going to use the substitution technique. So I'm going to say put 1 in 2. So where I see y, I will put that expression. So this is 2x minus 2 is equal to 4. Alright, which implies what? You fall this out, it's 2x squared minus 2x minus 4 is equal to 0. So I'm transposing the 4 to the other side, which also implies that x squared minus x minus 1 is equal to 0. What happened here? I literally divided by 2. So you may just write these things out like that. If you divide by 2 throughout in there, you get here. So that's what happens. But you may not need to explain this thing. So most likely when you factorize, you will win. Sometimes you don't. So this is x. Factors of what you call, when I made a mistake here. This is not 1. 4 divided by 2 is 2. So this is going to be 2 and 1. And then of course we make this one negative and this one positive. So we can say therefore our x is equal to what? Sorry, minus 1, or x is equal to 2. Which also will conclude for us that y is going to be 2 into minus 1 minus 2, or y is going to be equal to 2 into 2 minus 2. This becomes minus 2 minus 2 is minus 4, or y is effectively going to be equal to 2. All right, great. And then of course you test this set of values. So you will test this guy together with this guy. You substitute them back into one of the equations, and then you see if the left hand side is equal to the right hand side. For example, we substitute here minus 4. So we have minus 4 on the left hand side. Here's going to be 2 into minus 1, which becomes minus 2. Minus 2 minus 2 is minus 4. So minus 4 is equal to minus 4. So this should be correct. Of course, guys, double check. Coincidences sometimes do okay. You find that one pair works, but the other one doesn't. So if it doesn't work, it means something is wrong. Okay. So you get marks for those 4, and then you get a mark for substituting one into the other. So that's how you get those 5 marks. Sometimes they push it to 6 marks to try and capture this factorization that you may have to do there. Alright guys, not a problem. So let's solve 1.3. 1.3 says, show that this expression is even for all positive integer values of n. Okay, Let's see what we can do here. So we've got 2 times 5 to that exponent n minus 5 to the exponent n plus 1 plus 5 to the exponent n plus 2. Okay, so how do we solve this? We just simplify. So here we first show that this is 2 to the 2 times 5 to the exponent n minus 5 to the exponent n times 5 to the exponent 1 plus 5 to the exponent n times 5 squared. So just using exponential rules to, break those exponents that are complex. And then we look for the highest common factor, which is 5 to the exponent n. What we're left with inside is 2 minus 5 plus 5 squared, which is just 5 to the exponent n equals, and then here 25 minus 5 is 20, plus 2 is 22. Now remember, if you multiply any number by an even number, the answer becomes even, okay? That's just that, because when you say it is even, I think the interpretation, when you say even, it is either divisible by 2 or the value is a multiple of 2, okay? So this is an even number. So if you have an even number here and you multiply into any value here, it gives you an even answer, isn't it? Yes. Yes, so you can stop here, or you can show that this is effectively a multiple of 2. So this is 5 to the exponent n into 22 is basically 11 times 2. Yeah. Maybe let's put our times properly so that it's easy. So here you can already tell that, look, you can either stop here or you can stop here. The key here is that you're just showing that this thing is a multiple of 2. Of course, considering that this is a positive exponent, okay? Because we're saying positive integers, which is effectively natural numbers starting from 1 to infinity. The problem, if you put a negative exponent, you get a fraction here. Now this becomes a fraction of whatever you have here. And the problem is that the answer may not be even. So that's why we're only considering the positive integer values of. So you can get your mark there or here. It's up to how you see this. And then of course breaking this apart using exponential rules is important, and then getting the highest common factor and sorting out is good. And then of course you make the conclusion. You can say therefore the expression is even for all positive integer values of n, because you must always answer the question that was posed. Don't try to do your things. Of course, this is not 4 marks. It's either you stop there, it's acceptable because this is a number divisible by 2, or you can show that this whole thing is essentially a multiple of 2. Okay, I think we're done with those 3 marks. Let's do the last one. So try to do question 1 in 30 minutes, okay? Don't go too far away from 30 minutes. Now it says determine the values of x and y if 3 to the exponent y plus 1 over 32 is equal to the square root of 96 to the exponent x. Now we've got these bases here. So focus on the bases and see what you can do about them. This is basically 32 to the exponent 1 at this point. You don't want to complicate your life. And then we have a 96. Now the key is for us to do elimination techniques, for us to solve this easily, we need to try and show that these bases will somewhat look the same. Now if you look at 96, 96 is basically in relation to 3. Let's see, 96 divided by 3, where's my thingy? 96 divided by 3 is 32. So 32 times 3, so do you see we're getting this base and this base right in here. So that means we have to split 92 into 3 times 32. Then all of that to the exponent x. So it makes life a bit easy. So we have 3 to the exponent y plus 1 over 32 is equal to the square root of 3 times 32 all raised to exponent x. Okay, so you see when you inspect these things and try to relate them somewhat, you get a bit of a direction. Otherwise it can become a situation you really do not desire because it becomes longer than you actually would want. Okay, let's see, this is over 32 is equal to, so when you remove this using surd rules, it becomes 3 times 32 into x over 2. Okay, this is when you write this in exponential form. Now you realize that, okay, I'm gonna have some base 32 raised to exponent x over 2. So how do I make sure I reconcile this on that side? You simply change this to a negative exponent. So we're going to have 3 to the exponent y plus 1. So when you put it back into the numerator, this is the same as times 32 to the exponent minus 1. Yeah, is equal to, you distribute the exponent inside, is 3 to the exponent x over 2 times 32 to the exponent of x over 2. Alright, so this is good because now you've got these powers, that power and this power. The power, remember, is the whole thing. Base and its exponent makes a power. Now you've got two powers side by side of an equal sign and they have the same bases. So what does that mean? We simply will equate the exponents. So that makes life a bit easier. So we can just rearrange this thing and say 2 to the exponent x over 2 is basically equal to 2 to the exponent minus 1. Now, which also implies that when you have powers with the same bases on either side of an equal sign, you simply equate the exponents. So x over 2 is equal to minus 1. Therefore, x is going to be equal to minus 2. Just cross multiply that 2 there. Quick techniques. So do you see, as much as you're trying to make this shorter, but it becomes a bit longer. This also implies, now you look again in the expression, what looks similar to the other one. So you've got that power there and this power. So what do you know about those two powers? They have the same base but different exponents. But what does that mean when they're side by side? It also implies that 3 to the exponent y plus 1 is equal to 3 to the exponent x over 2. So therefore, okay, not therefore at this stage. So this also implies that y plus 1 is basically x over 2. And we can simplify there and say y plus 1 is going to be equal to x is minus 2 over 2. Therefore, y is going to be equal to minus 2y. This is minus 1. Minus 1, it becomes a 2. So you get the answers for those values. And then, of course, to make sure they are correct, you substitute them into the original and see if the left-hand side is equal to the right-hand side. So when I get 3 to the exponent, by the way, it's going to be y is minus 2. Minus 2 plus 1 is to the minus 1. Okay. So divide by 32. What I'm getting here is 1 over 96. Okay. This is 1 over 96. And let's see here when you do the square root of 96 to the minus 2 as well. What is that? It's 1 over 96. So these two values are correct. So How do you get these 4 marks? Technically, I think this step is mark worthy. So we already have 3 marks here. I don't know, guys. There's a lot of things that we needed to do here. So I'm trying to figure out what. Maybe breaking this one into these 2 is where you get the 4th mark. I mean, it can be anywhere. So there's a lot of things you did. Maybe the substitution somewhere. Doesn't really matter. What matters is that we got all the marks. Okay, guys, I wasted time. So don't take longer than 30 minutes, honestly. Answering question 1. It's important. But because I'm trying to teach you a thing or two, so I can do that. Question 2 says the first term of a geometric series, it's a GS, okay, is 14. Okay, and then what are we told here? We are told that T6 is 448. Okay, so these are simultaneous equations. So when we discussed the GS as well as the AS, I've shown you all the tricks that you may need to use in these things. Of course, others are there to be discovered when you get some strange questions. But nonetheless, everything is pretty easy. So it says calculate the value of the constant ratio. So we can say 2.1, we've got 2.1.1. So in this instance, we are told that A is 14, and then we are told that T6 is equal to 448, okay? Which implies T6 is AR to the exponent 5 is 448, which also implies A is 14, they told us, times R to the exponent 5 equals 448. So we simply divide by 14, so R to the exponent 5 is equal to 448 divided by 14 is 32. This also implies that R to the exponent 5 is equal to 2 to the exponent 5. Of course, when things don't look alike, you always try to make sure the exponents look the same. Now I've got these 2 powers side by side of an equal sign with the same exponents. You see, the exponents are the same. So what does that mean? We can simply equate the bases. R is going to be 2. That's the answer. Okay, so they are just giving you 2 marks. Guess is the correct substitution into the correct formula and the answer. The rest, they're not interested because it's applications, applications, applications. Next question says, determine the number of consecutive terms. So this means terms that follow each other sequentially. So that must be added. We're adding these ones to the first 6 terms of the series. Okay, so first 6 terms of the series in order to obtain this number. Okay, so what are we going to do here now? We have to set up some kind of an equation. So 2.1.2, we are told here that S6, because the first 6 terms are going to be added together. So S6 plus some Sn, which we don't know, we are told it must be 114,674. Let's just double check that value there. Yes, 674. Okay, so now we know that this S6, remember the first 6 terms have been added. So what will be the first term of this sequence? This sequence right here, the T1 of it is effectively going to be equal to T7, isn't it? So that is the most important thing, that for the next series, because we are told this should be consecutive and they must be added to the first 6 terms. So this is saying we need to find T7 here. Okay, So we can just say T7 is going to be equal to A, which is 14 times 2, AR to the exponent 6. So let's see what that is. 14 into 2 to the exponent 6 is actually 896. Okay. So these are the things you need to make sure you think about. And then now what does this imply? It implies that our S6, which is 14 into R is 2 raised to the exponent 6 minus 1 all over 2 minus 1 plus this Sn, which we don't know. But we know that the A value here is T7. So which is going to be 896 into, the common ratio is the same, but now we don't know the number of terms that we must add from that 7th term. Okay, so this is 2 minus 1 is equal to 114674. All right, so do I have enough space? Doesn't look like it. Yeah, when? What happened? All right, so we can clean this thing up and see what we can do here. So we have 14 into 2 to exponent 6 minus 1, literally over 1. Okay, what is that? This is 882 plus, this is literally 896 into 2 to the exponent n minus 1 is equal to 1146. Sometimes this thing does its own thing. Okay, now you can already tell that the gymnastics that we need to perform here, I'm looking at the space and I'm feeling a little bit under pressure. I don't know why this took forever here. I'm feeling a bit under pressure now. So what we need to do, we transpose this guy to this side. So meaning it's going to be this one minus that, divide by that, plus 1. Okay, so we know that all we're going to end up with is basically 2 to the exponent n is equal to this one minus that, first of all. So it's 114674 minus 882. And then we get whatever value we got, and then we divide by 896. And then we're getting 127, and then we're going to transpose this one to the other side. So we add 1 to that, we get 128. I'm sorry guys, I kind of ran out of space, so I couldn't do the whole little thing that you like. So now this is what this means. And then of course this will also imply that 2 to the exponent n is equal to, so you can try and see if you can't express 128 as a power of base 2 raised to some particular exponent, because we want to solve there, but we need these bases to be the same so that we can equate our exponent. So just press shift onto 121. So you press shift and then you press fact. You know that this is going to be 2 to the exponent 7. Some people already know this one. So now you have what you needed. Powers with the same base side by side of an equal sign. Therefore, n is going to be 7. You can then make a conclusion and say, therefore, 7 consecutive. My consecutive needs a lot of work. So, therefore, 7 consecutive terms must be added. You can stop there to the first 6 terms. It's fine. To the sum of the first 6 terms. Now, you want to double check if this is true. All you need to do is to just put 7 where n is on this expression, and then you add those two values. If you have this side equaling that side, then it's correct. So you just have 896 into 2 to exponent 7 minus 1. Ne? And then we have 113,792. Then we add 882 to that, and we get exactly this value. So this is correct. So that's how you get those marks, guys. So how many marks were on offer here? 4 marks. Okay. It wasn't really an easy question. It was a bit difficult. So we can just say general substitution is important here. But in particular, finding that T7 is important. Okay, so you can mark it there. You can just mark the general substitution. Is up to you. So you've got 2 marks there already. And then what you've got here is, of course, the answer is a mark. So we already have 3 marks. Maybe converting 128 to this is where the 4th mark is, but it can be anywhere where they choose that it is important. But I can tell you those 3 positions are essentially where you would get those marks. Okay, let's move, guys. We don't have time. Now it says the first term of another series is 448, and then T6 is 14. It says calculate the sum to infinity. Already it tells you that this will be, you can see these things are switched around from the top to the bottom. So we got R as 2, so here is going to be the reciprocal, which is a half. But let's check if it is so. So here we know that our A is 448. And then we are told T6 is 14, which implies that R to the exponent 5 is 14. A is 448 times R to the exponent 5 is 14. Alright, so this implies that R to the exponent 5 is equal to, you divide by 448, so 14 divided by 448 is 1 over 32. And this implies that R to the exponent 5 is 1 over 2, or raised to the exponent 5. Okay. Now the key is you wanted the exponents to be the same, so that we can simply equate the bases. So you can simply say, therefore, R is a half. Okay. Now we can say sum to infinity is A over 1 minus R. This is when R is less than 1, greater than minus 1. So A is 448 over 1 minus a half. So let's see, this is the same as 448 by 2, which is 896. Okay, so it gives us this 7th term in the previous series. So it becomes, this is where the series converges. So even if you add more than these terms here, if you add terms, once you get to this, you'll get the same answer throughout, no matter how many terms. As many as they are that add up to this, then after this there will be the same answer or same value. So you get the mark for finding R, you get a mark for correct substitution, you get a mark for the answer. That should be fine. 3 marks. Okay, 2.2. Yeah, these guys are not tiring. Yeah, they are not tired. They keep asking, come on. But let's finish these questions quickly. All right, so we have here sigma starting from K. So starting from P0 to K up there of this expression. But what you notice about this expression, there is a variable here. Oops. There is a variable P with a coefficient. So the coefficient becomes the gradient because it's constant. P is a variable. And then we have a constant term, which is 1 over 6. So this is linear. Okay, so you can already tell this is an arithmetic series. So inspecting these things will help you to know what you're supposed to do instead of trying to figure out what this is. But at times you may have to, you never know, but yeah, just do that. So we can already say to ourselves here this expression here is such that, this whole expression, okay, maybe let's write it. This is such that when you put 0 in here, you get 1 over 6. It's 1 over 6 plus you put a 1, so it becomes a third plus that 1 over 6, so a sixth there. So we get a half. Just expand to at least 3 times. Then you put a 2 there, it becomes a 2 over 3. So you see with your fancy calculators, you just sort up some numbers, you get a 5 over 6 plus dash dash. But you don't worry about the last term because it's complicated. It has a p there. It has a k. So we are told if you sort this mixed fraction, it's 121 over 6. Okay, so now what do we have here? We can see that, well, if we say, for example, a half minus 1 over 6, what is that? We're getting a third. Okay, so we can tell that d is going to be a half minus 1 over 6, which is equal to 1 over 3. So this is important. You can check this one as well and say, okay, it's going to be it's going to be 5 over 6 minus a half. So we're getting a third. So this is our D. And this is our A. So this is our A in this whole thing. So that is our A. This is our D, which is the common difference. So let's move, guys. Hey. I like to lose time unnecessarily. So what is the number of terms here? The number of terms is always going to be the top k minus the bottom, which is 0, and then you add 1, which is k plus 1. Okay, so that is the number of terms. That's another important step here. Okay, let's try and solve this thing now. So we are told you find the values of k. Okay, so what is that? What we can do, we know that this is an arithmetic series or sequence, so we can say here Sn is basically equal to 121 over 6. That's what they told us. But what is Sn? Sn is basically n over 2 into 2a plus n minus 1 times d, which is the last term. Now this is equal to 121 over 6. Which, okay, we can say this implies maybe not there. And then this implies what? What is n? We got n is k plus 1 over 2 into 2 into the first term, it's 1 over 6. We got that. Plus, here we're going to have k plus 1 minus 1 times d, which is the third, is 121 over 6. Okay, great stuff. So this implies what? We've got here k plus 1 over 2. Let's clean this whole thing up. And when we clean this whole thing up, we get here, this is basically a third plus, so this is 0, so it's just a third multiplied by k, which is the same as k over 3. Okay, equals 121 over 6. Just trying to squash things here. Now we've got k plus 1 over 2 into, when you solve this, it becomes k plus 1 over 3 is equal to 121 over 6. Then now when we multiply these things together, let's do one step here. It becomes k plus 1 all squared, all over 2 times 3 is 6 is equal to 121 over 6. And then you just simply cross multiply that. And then this will imply that k plus 1 all squared is equal to 121. Okay. Now what do you do at this juncture? You take the square root sign because you want to solve for k. What you do on one side, you must do on the other. So this implies that k plus 1 is equal to plus or minus 11. And therefore k is going to be, so 11 minus 1 is 10, or k is going to be minus 11 minus 1 is minus 12, which is not allowed because here k cannot be any negative integer, but it's a natural number. So meaning k should be 10. All right, not a problem. And then of course you can tell that the number of terms is basically 11, but k is 10. Okay, that's the most important. Now you can double check and be sure that this is the case. So we can just substitute into the original formula the value of k and see if we're getting this value over here. So k plus 1 is 11. So let's just say 11 over 2 into 2 into 1 over 6 plus, now here it's just going to be the value of k, which is just 10 multiplied by a third because the ones cancel. And then let's see what we get. I'm getting 121 over 6, so it means our value for k is correct. So this is important, not a problem. 1 mark over there. And then I'm sure getting the common difference is important, second mark. And then getting the number of terms as k is there. 1, 2, 3, so that's the third mark. Then the fourth mark is the correct substitution into the correct formula. How many marks are we getting here? 5. And perhaps for your inverse operations here, that's where the other mark comes from, which is quite key areas. And then of course, yeah, that's how you get those 5 marks, guys. Let's drill question 3 quickly. Let's drill question 3 nice and easy so that we can enjoy our functions quickly. So we don't want to waste too much time. Question 3 says the general quadratic number pattern. So this is quadratic number pattern. So the Tn is this one. Okay, so if you inspect here, the coefficient of n squared, which is a, is 1. Remember, a in a quadratic number pattern is not the first term, okay? The first term is a plus b plus c, okay? Remember that. So a here is is 1, because when it's not written, it's an invisible 1. Then we don't know the b, plus 9, okay, not a problem. And then we are told the first term of the first differences is 7. So what does that mean? Well, it means what it means. You know that the first term of the first differences can be written like this in general, is 3a plus b. So 3a plus b is 7. That's what it means. So it says show that b is 4. Now I see 2 marks. So let's quickly do this one. 3.1, we know here that, well, a is equal to 1. That is important. It is the coefficient of n squared in the general formula, right? You don't have to explain. I'm just giving you, a bit of conviction that it is so. Then we are told also that the first term of the first differences, we are told that 3a plus b is equal to 7. Again, if you don't remember this, go and watch the lesson on the quadratics that I did. You will be refreshed there, which implies that 3 into 1 plus b is 7. Therefore, what do we have here? B is equal to 4. There's someone on the gate. I'll just come back. Okay, guys, I'm back. Sorry for that interruption there. So this is the answer. So you see, they already gave you the answer so that you can have an idea as to how you're going to solve that problem. So you're getting 2 marks. The correct substitution into some correct formula, you get the mark. But I think you're not getting a mark for the substitution at this point. Technically, the value of A is what is important, basically. The substitution is actually the value of A. We can mark it there, you can mark it here. Alright guys, so let's just do this thing. It says now determine the value of the 60th term of this number pattern. So 3.2. We know that our Tn is now n squared plus 4n plus 9, isn't it? So this implies that T60 is going to be literally 60 squared plus 4 into 60 plus 9. Okay, let's see what we've got here. 60 squared plus 4 into 60 plus 9. So I'm getting here 3,849. Okay. Make sure you guys, everything is on point, or else there's going to be a bit of pain. So this one is simple. Substitution, answer. You score those 2 marks. Now 3.3 says, I hope, yeah, I didn't put anything. So 3.3 says determine the general term of the sequence of the first differences of the quadratic number pattern in the form TP equals NP plus Q, which is basically linear. All right. You're just going to express it as if you are dealing with a straight line equation. But let's see, we were told that here, now remember this is a linear number pattern. So we know that T1 is equal to 7 of these first differences. So that one is sorted. We also know that the common difference or the constant difference is given by this expression. Where does this come from? It comes from the general information. So if you are a bit beat down by this one, please go check the video that I have produced on the quadratic. So we know that A is 1, so D is effectively 2. That is it. So what is left now is to say this implies that Tn is going to be equal to, let's just say T1 plus n minus 1 times D. I'm just running away from using A because A here is part of the common difference there. So T1 was 7 plus n minus 1, which is what we don't really know at this point, into 2. This is 7 plus 2n minus 2, which is 2n plus 5. Okay, so this is it. This is it. That's the answer they wanted. So do you see, I mean, you can go about it the long route. First, get the terms of the quadratic and then do the first differences. Then you do the whatever A value, and then you can just eventually do this nicely. But this is nice because you just zoom into some things that you remember and you sort it out. All right, guys, I'm wasting too much time here. So let's do the last question here. Last question says, which 2 consecutive terms in the quadratic number pattern have a first difference of 157? So 157 is between certain terms. So now that they asked us this equation, so we can actually sort it out. Let us see here. This is question 3.4. Sorry for that. So question 3.4, what we've got is that we know that Tn is equal to 151. Is it 151 or 157? 157. But which Tn? It is that Tn. So what is it? So we know that this implies that 2n plus 5 is 157, which also implies that 2n is equal to 157 minus 5 is 152, right? Right, so we can say, therefore, n is this one, 152 divided by 2, I think it's 76. Let me just check. 152 divided by 76, well, not 76, but by 2, yeah, it's 76. So what can you say? You can say, therefore, 157 is the difference between t. Now, if you've got 76, it's going to be 77 and T76 of the quadratic progression. You can say QP or quadratic number pattern. Ne? So how do I know this? I mean, if you watch the videos that I've shown you guys, especially the prelim video on the Gauteng exams last year, the prelim exams, you will notice that this particular number, which is T76, which is 157, its position in its sequence of the first differences will coincide with the position of the lower of the two that make it up. Ne? Just remember that. Okay. But there's plenty of other ways you can actually show this directly. Alright, not a problem, guys. Let us see how many marks were on offer here. 3 marks. Okay, that's fine. It's easy. Technically, it's just correct substitution into the correct formula, getting this answer and making this one, because this guy here was not quite obvious, but you have to understand your math. Okay, so do you see we've sorted question 3 in exactly an hour and some minutes? Okay, so make sure you try and replicate that when you're doing your exams. Let's quickly look at this hyperbola. So we are told here, sketched below is the graph of h of x equals 1. So look at that. That 1 is a. So what does that tell us? It tells us that a is greater than 0. So therefore the graph, we expect it in the first quadrant and third quadrant. And are we seeing something like that? Yes, of course, it's shifted about, which is those asymptotes. The asymptotes basically shift the axis, so to speak. Now we're told the asymptotes of h intersect at this one. So this point is the point of intersection of the two asymptotes. That point of intersection of the asymptotes is basically the center of this graph. And it literally defines our function. So we can tell that therefore h of x is basically 1 over x. Now when you put 1 in here, the vertical asymptote, you put it in the opposite sign. Okay? But the horizontal asymptote is put just the way it is. Just the way it is. Okay. So that is fine. So we're literally given this equation indirectly. Is there anything else we want to say at this point? The answer is no. Okay. So let's just quickly get to this question. So write down the values of P and Q. Do you see they don't want an explanation? They just want the values. So 4.1.1. We know that P is -1 and then Q is a 2. So you get marks for that. 4.1.2 says calculate the coordinates of the x-intercept of h. So now that we know that our h of x is 1 over x minus 1 plus 2, we know that for x intercept, it is such that 0 is equal to 1 over x minus 1 plus 2, which implies that minus 2 is equal to 1 over x minus 1. So this is over 1. Cross multiplication gives us a situation of minus 2x plus 2 is equal to 1. You can say here, therefore, x is equal to, when you transpose this, you get minus 1. Minus 1 divided by minus 2 is basically a half. We can say, therefore, the x-intercept is such that a half is to 0. Because they said coordinates, y is 0 there. So you get a mark here for getting that x value, and you're showing those 2. How many marks were they giving you there? 2 marks, yeah. The rest is history. The rest is history. Okay, not a problem. The next question says, write down the x coordinate of the x-intercept of g. Now we have another function when g of x is this function. Okay. So do I have anything? Yeah. So do you see, I almost killed myself here. So what we can say here is, if g, we basically notice that, well, g of x is the graph of h of x translated to the left 3 units. Okay, so if you're having a situation where you're adding to the x values a3, this is a left shift, or you call it a translation. So therefore we know that the x-intercept of g of x will be such that x is equal to that x-intercept of the first one, but minus 3, okay? Which is going to be 2 there, it's 6. Therefore, this is minus 5 over 2. So they said the x coordinate. So, I mean, all of this is just the thought process you want to go through. They just said write down. So when they say write down, you can just write x is equal to minus 5 over 2. So that's where you get your 2 marks, okay, for the answer basically. But there's nothing wrong, even if you wrote it this way to just show them the thought process, they will not penalize you for that. But you won't get extra marks for doing all of that. That's just the thing. If the answer is 2 marks, so any explanations are just for yourself, to just show that you understand maths, but they're not interested anyway. No rewards for it. Okay, so 4.1.4, it says the equation of the axis of symmetry of h is this one. So if you inspect that, the gradient is 1 here. So it's positive. So this is a graph of the axis of symmetry that passes here. All right, so this is it. So this is y equals x plus t. Now we can already tell that this passes through the point of intersection. So this point belongs to this line. And this line has a positive gradient. So we're interested in t, but what is t? T is literally this point here, the y-intercept of this line. And if you're looking at this, it's exactly above 0. So we expect a positive answer. So if we get something else, we know we are not doing well. Okay. So honestly, what you have to do here is very easy. You just say, well, y is equal to x plus t, then through this point of intersection of the asymptotes, because it is a point on that line, it is such that 2 is 1 plus t. Therefore, t is just going to be 1. Alright, so that's what we wanted to solve. So correct substitution and an answer gives you the 2 marks on offer there. And you can already tell that on the graph, even when you do it. But remember, these things may not be drawn to scale. But I like when the graphs, even though they're not drawn to scale, they still make sense. Because let's imagine this thing showed up here. It would not make sense at all. And that would have been crazy. So at least whoever did this maintained the reality that is trying to be portrayed in these questions. Alright guys, let's just keep moving. No waste of time is necessary here. So we told you, determine the values of x for which this is the case. Now, you ask yourself, what does this thing look like? Well, you can see that there's a minus 2 here. There's 1 over x minus 1. So this is literally our function of g, but messed around with. So as if we solve this thing here, we can tell that we will have here 0 is less than or equal to 1 over x minus 1 plus 2. And this implies that 0 is less than or equal to, oops, not f but h of x, because this is the graph of h of x. So whenever they give you anything silly here, it is almost always related to the graph that you've been given. So try to find the link, then you'll be able to answer. So this could be simply put as h of x is greater than or equal to 0. Yeah? So this format makes a lot more sense than the other one. The other one may throw you off. So the key thing here is to say h of x must be greater than 0. So meaning, when is this graph appearing above the x-axis or at exactly the x-axis? And we know that if we're looking at this graph, we can see that this graph here is above the x-axis until that x-intercept. And it also appears above the x-axis in this region. So what are the critical values here? Is the x-intercept here and this vertical asymptote. Alright, so you can already tell that here this point is included. This point is included here. But this one cannot be included because it's an asymptote. It's where the graph is not defined. Alright, so we can solve our problem nice and easy. We can just say, therefore, x must be less than or equal to the half, which was that x-intercept, or x must be greater than 1. So do you see? You've got these ones. So you can write this, that you get your 2 marks. And then the third mark, I mean, it's your gymnastics here that you had to do. I don't know, man. You can get it here, you can get it here. It's really not a big deal. So for me, I would say, making sense of this thing and then answering in a sensible way is what is important. Okay, that's how you get the 3 marks in that question. So let's get to the 4.2 segment here. Now we're told here the graph of f. Okay, so there is f of x. So this is a parabola. And what do we know about the parabola? You can tell that a here is greater than 0. So you expect your parabola to be smiling. So if this is your graph, you expect a parabola to look like that. And then, of course, you have your y-axis here. So you have a smiling parabola. So do you see something like it? Yes. So there's no manga business here. No translations of shifts, at least for now. And then the constant term is the y-intercept. So the y-intercept is over here. So we can tell that this is minus 5. Okay, maybe let's write it here. So this is minus 5. Okay, so it's C. X is 0 and y is minus 5. So indeed, this graph is not shifted about because a point that we can expect is exactly where we expect it. So there's no manga stuff here. So we're looking at g of x. Okay, what is g of x here? G of x is basically the exponential graph that is shifted vertically only. So this is grade 11 stuff. So let's look at this one. Now we have base 2 which is greater than 1. So this is essentially potentially an increasing function or a decreasing function. It doesn't matter. But the characteristics of A is what we need to establish. We know that A tells us that the graph appears above or below the horizontal asymptote, which is Q. So when A is negative, the graph will appear below the horizontal asymptote, which is that value of Q. When A is greater than 0, the graph will appear above the horizontal asymptote of that one. So of course, when A is positive and B is greater than 0, there it's an increasing function that appears above the horizontal asymptote. But when A is negative and B is more than 1, then we know that this becomes a decreasing function which appears below the horizontal asymptote. Okay, these are some of the things you want to establish in your mind. Now as sketched below, so E and H are the x-intercepts of F, so there they are, not a problem. C is the y-intercept of F, which also lies on the asymptote of G. So this means this is the asymptote, y is equal to 5. Okay, so that's the asymptote line. And look at this graph. This graph is appearing below the horizontal asymptote. So it means our A here is less than 0. So keep in mind that when you solve, if you have to, you expect a number that is negative. If it is negative, it would be a matter of the actual numbers than anything else. And then we're told you the two graphs intersect at D, which is the turning point of F. So if they don't state that D is the turning point, it would almost be difficult to think of it that way. So it's important. So this is an important statement to say, but the others are pretty implied, so you would not really need to have that one explained to you. Okay, now let's see. Write down the y coordinate of C. We already saw that it is minus 5, so they said write down. So we can start here and say 4.2.1. So y at C is basically equal to minus 5. We get our answer, we move on. Determine the coordinates of D, which is the turning point. So the coordinates of D, so this is basically 4.2.2, sorry. So we know that D is such that, we can use any formula that is relevant. So we know that, the x at D, sorry, not at B, but at D is going to be minus into minus, what was that? Minus into minus 4, okay? Over 2 into 1, isn't it? Because we're just using those nice formulae to solve our problem. So x at D, this is basically 4 divided by 2, which is 2. Then we can say also, we know that y at D is going to be equal to, you can use any formulas that you know of, but it's going to be basically f at 2. So when you put a 2 there in the expression, in the equation, 2 squared is 4, right? 4 times 2 is 8, so 4 minus 8 is minus 4. Minus 4 minus 5 is minus 9. You can show the actual substitution. I don't know if it is really significant, but you're getting here only 2 marks, so I don't think a complicated thing is that really relevant. So you can say therefore D is the point 2 is 2 minus 9. Again, a point of note is that when you're showing the coordinate pair, we separate the two values, the x being the first one, the y being the second one, with a colon. Is it a colon or semicolon? Yeah, this is a semicolon. So we use a semicolon. Please don't use a comma. That's not the notation we use here in RSA. But I'm not sure if your exam guidelines exempt you for using a comma instead of a semicolon is fine, but I know that they use a comma in the US, not in South Africa. So pay attention to a few small details. They may save your life, because if you end up with a comma, you may find yourself marked down because it would just show up as 2.9, which we're like, what is that? Anyhow, there's no need to overly explain things here. So 4.2.3 says determine the values of A and Q. Of course, now we are sorted here. Let me see. I didn't write anything down. Okay. So it's 4.2.3. Of course, I know that G of X is given by A times 2 to the exponent X minus 5. That I've already discovered, because minus 5 is the horizontal asymptote. We can say, therefore, Q is equal to minus 5. I mean, it's as simple as that. So, I don't know. We can say also G of X being equal to A times 2 to the exponent X minus 5. Through point D, which we just found above, it is such that minus 9 is equal to A times 2 to the exponent 2 minus 5. This implies what? We transpose that, it becomes minus 4 is equal to, this is 4A. Ne? Yeah, man, therefore A is equal to minus 1. Didn't we say we're going to find something? Yes, we did. So, what can we say? What we can actually say is this. There's nothing more to say. How many marks are there? 3 marks. I'm sure you're getting a mark for this instance here, the correct substitution into the formula and the final answer over there. It makes life a bit more sensible. Okay, let's get to this 4.2.3. I think I'm getting too relaxed here. They want us to write down the range of G. So if we're looking at this equation quickly, we can see that this graph here of G, this is its horizontal asymptote, and the actual graph of G is this one. So we can see that it appears below that horizontal asymptote, which is 5, and this goes on until infinity. So that's the range in the vertical axis or in the y-axis. So I like to write range is equal to the set of y values such that y is less than minus 5. You can leave it like that. Or some people can say y is an element of minus infinity going up all to minus 5, but none of them are included because that is an asymptote, so you cannot include it. So you make round brackets. Again, you do this in the event that y is an element of real numbers, and it is so, except that there's a tight restriction on minus 5. All right, guys, now that is fine. So you can write that. You can even write y is less than 5 alone without this information, but this is more complete when you write it that way, and maybe this one. So either one of the two will give you your 1 mark. Next question says, determine the values of k for which f of x minus k will always be positive. Okay, so now what is that? So if we inspect here, k is basically a constant because it is standalone. And then this is the function of f. So if this is a constant and we're subtracting it, this simply means we are doing what is called a vertical shift of our parabola, or you can say vertical translation. All right, now when can we do this? So let's see, if we shift our parabola around, there's two ways we can shift it. We can shift it down. Let's say this is shifted down here, so you have our d prime here, which is the new one. So if we do our parabola, it will still do its own thing, turn up here and then go all up like that. But do you see, this graph is not necessarily positive. I mean, it goes on and on. Hey, don't do those things, Wena. So it would go on and on and on and on like that. So there will be a portion that is positive above the x-axis and the portion that is negative. So we're talking about y values here. So this shift downward will not help. But what will help is actually shifting it upward. You can shift it up until there. Then the graph would look something like this. Now, do you see here? It's positive, 0, and positive. So we don't want 0. 0 is not part of the game here. So what else can we do now? We can actually shift it further. So we're shifting it from all the way from this part to somewhere up there. So if we shift like that, this is how our parabola would look like. And do you see? If we shift it more than this value, remember the y value there was -9, so it's 9 units. So if we shift it upward by more than 9 units, this graph is effectively all positive at the minimum value and other values. Okay, so we need to find a way. So the keyword is this distance here, which was 9 units. Remember that was from 0 to -9, so it's effectively 9 units. So that is the key. But then we want to shift it by more than 9 units upward. But you will have to adjust for the expression given, because the expression given is doing a bit of a silly thing. Do you see there's a negative here? So you have to correct for this negative. So all I can say here is that k, I know that k here must be less than -9, right? Because let's say we put a -10 in there. Minus into minus is going to be a plus. So it's going to be f of x plus 10. So that means it's correcting for that negative. So be careful of these kinds of things. So you get 2 marks. I mean, the answer alone will give you 2 marks without explaining. But if you want, you can say, this is a vertical shift by k units. Therefore, you answer your thing. But you can, at some point, do an algebraic calculation to solve this problem. So you know that f of x minus k must be greater than 0. So this statement here is written mathematically like that. But what are we looking for? We want the minimum value to be positive. What is the minimum value there? It is -9, because that's the y value at the turning point. Minus k is greater than 0. Then you transpose k to this side, -9 is greater than k. Or simply put, you can say k is less than -9, because that's what this means. So you see, there's a few things you want to make sure, but make sure here you know what value to put in there, otherwise you're going to be in trouble. So again, for doing all this hard work, you're not going to get a mark, but only for the answer. But sometimes if you did it this way, someone may say you get a mark for this correct substitution of, or even this just expression itself, 1 mark, and then for the final answer, 1 mark. Makes sense? Nah. All right, guys, so that is the end of that question. So let's rush through question 5. See what is in there. So question 5 says the graphs of G, okay, that's a straight line, is equal to 2x plus 6, and the inverse, okay, the inverse of g are shown in the diagram below. Okay, D and B are the x and y intercepts respectively, so we can see there is the story. And then of course, if that is the y-intercept, it should be the constant term, which is 6. And then we can calculate, if you transpose 6 to that side when this is 0, we get a minus 6 divided by 2, it's a minus 3. So that is what we have here. So these are the things to quickly think of, okay? Don't waste time to be asked a question. And then of course we know that the inverse of a straight line is basically a straight line with a positive gradient if the original graph had a positive gradient. But the difference with those two gradients is that they are reciprocals of each other usually. If this one is, say, 2, for example, this one is going to be a value less than that, okay? And vice versa, okay? All right, not a problem. And we also know two things, that these inverses intersect at a point such that the x value at that point is exactly equal to the y value. How do we know this? So let's say, for argument's sake, this is minus 4 and then this is minus 4 as well. Why do I know that? I know that because the inverse line passes through the point of intersection of these two values, and it passes through the origin. It is the line y is equal to x. So remember, if x is minus 4, what is y? It's minus 4. So this comes from that knowledge. All right. I'm happy though. My student, I think few days, was it the day before the exam, was a few days before the exam, maybe 2 or 1 day before the exam, we actually discussed this, that these will always intersect on this line, as much as I may not have interpreted this one for him, but it actually makes logical sense. So I mean, we've worked through this one a little bit, and then we are told here C is the x-intercept of the inverse. Okay, so that one we can see it over there. And then the graphs of G and the inverse intersect at A. So we can see there. I mean, this is just hypothetical values that I'm putting. Otherwise, don't pay too much attention to them. So the question says, write down the y-coordinate of B. So what is B there? We saw that it's 6, and they said write down. So this is 5.1. So we know that y at B is equal to 6. No questions about it. 5.2. It is the y-intercept of that line. It says now determine the equation of the inverse in the form the inverse of G in terms of x is equal to mx plus n. Of course, that form is great. So we can say the inverse of G. Okay. First of all, we can say such that we have x is equal to 2y this time plus 6. So you switch the y values and the x values, which will imply that 2y is going to be x minus 6. Therefore, y is going to be a half of x minus 3. Holy, holy, holy. Now, look at that. Look at that. Do you see that this gradient is the reciprocal of that? Definitely. So those are inversely related, technically or technically. Anyway, guys, so we can say now our conclusion, because they gave us a format to write this answer, is going to be half of x minus 3. And then you can already tell that if this is a constant term, it already tells us that this graph cuts at minus 3 right there. Okay, so you have a minus 3 there where that inverse line cuts the y-axis, and you can work out what is that. So if you work that out, you make this 0, If you make 0 here, you will transpose 3 to that side and cross multiply 2. It's going to be 2 times 3, which is 6. So it will always be like that. Remember, what was the y-intercept becomes the x-intercept by just understanding this, flip-flop. So that is it, guys. That is it, guys. So you can use any information to really structure your attack here. Okay, guys, let's move before I waste too much time. I don't want to do that, which is bad. Now it says determine the coordinates of A. So 5.3, we know that A is such that g of x is equal to the inverse, because they are both equal. So what is that? This implies that 2x plus 6 is equal to a half of x minus 3, which implies that we will have, you transpose this to that side, so we've got 2x minus a half of x equals minus 3 minus 6. This implies, when you take a half from 2, what do you get? You get 1 1/2. 1 1/2 is 3 over 2. Over, this is minus 9. And then, of course, if you divide throughout by 3 over 2, you will know that x is, say, minus 9. Minus 9 divide by 3 over 2 is minus 6. You can say, therefore, y is also equal to, you can substitute this into any of the formulas. You will get minus 6. Obviously. Obvious. So we can say now, therefore, A is minus 6 is 2 minus 6. How lovely. It's very lovely. Very lovely. Okay, guys, so that was easy. How many marks were they giving? 3. I guess correct substitution and the answer for x and the answer for y. Of course, you have to really show them in coordinate form, but the critical points is actually those actual calculations of the coordinates. Okay, so let's deal with this one. Calculate the length of AB. So now we've got 2 points. Is easy. So the length of AB is like this. So we know that AB is going to be equal to the square root of x at, say, B minus x at A, or squared, plus y at B minus y at A, or squared. Make sure the square root sign covers everything. So we will have here x at B is 0. Minus 6 is going to be plus 6 all squared, plus y at B is 6 minus 6 is going to be plus 6 all squared. So what I'm going to do here, you can just clean it up a little bit. So we've got 6 squared plus 12 squared is 180. You can leave it here. No one will punish you, but I like to write this one in simplest set form, which is basically 6 root 5 units. So the distance is in units, okay? Whichever they decided it is, okay? Usually here, correct substitution into a correct formula and the final answer. You can leave it here, no one will punish you. You can leave it here. But when they state that in simplest set form, this becomes the only answer. But at this point, it can be any of those two. All right. Now, calculate the area of triangle ABC. So let's look into our equations here. All right. Yeah, this is tiring. It's really tiring. Now, ABC is this one. A. Then we do BC. And we do AB side. Oops. So that is the triangle we're looking at. Okay. So guys, there's a few things you need to do here. Remember, as much as we calculated this guy here, this guy was not given. So we have to show how we got it if we're going to use that point. This guy here also, which is this y-intercept right here, we were not given. So it is implied in the calculation. So this is a bit simpler that way. So what I can do here is to divide my triangle into two triangles. So if I split them along the y-axis like that, I know that my task is to show how I got this and that. Because at the end of the day, I have the same base for these two triangles. So I've got this triangle and that triangle. So maybe let's use different notations. So let's say this is an asterisk and then this is two asterisks. Okay, so if you're looking at those two triangles, you can see that if I calculate this, I effectively have its height. Its perpendicular height is going to be that, which is basically 6 units. And then if I get this one, I will effectively get that line. And this one, the perpendicular height becomes this line outside. And they have the same base, so I can combine those two into the area that I want. So my task is to actually show that point C has that, and then the y-intercept of this one is essentially that. And then in fact we can call this one point E. Okay, we can call that one point E. So it makes life a bit easier, but you can do anything that suits your taste. So first of all, I'm going to say let the y-intercept of the inverse of G be, okay, maybe let's not say B, let's not write too much English, be equal to E, or be point E. We can say therefore E is the point 0 is 2 minus 3, because we've already found out that the inverse has the constant minus 3. So all you want to do, guys, you don't really want to do too many calculations, but you just want to show the logic that is linked. We can say also C is the x-intercept of the inverse of G, such that 0 is equal to a half of x minus 3. We can say, therefore, x here is going to be equal to 6. That's not quite nice. So you're moving quick here. You can say, therefore, C is the point, say when 6 is to 0. So these points has to come out. They have to come out, and you have to show how you got them, at least. Okay, not a problem. We can say, therefore, what? No, not therefore. This implies that the area of triangle ABC is going to be the area of triangle. Let's name it. We will start with this one. So this one is ABE. Plus area of triangle. Let's name that one as well. It's going to be BCE. I mean, the order in which you name them is not really big a deal. BCE. Okay, so that is important. And then now we substitute here. This is half. The base, we know that it's going to be BE times, say, H. BE times H. Plus, we can say half. The base is the same, BE. Maybe we can say times K. I mean, we have to just play our tricks a bit here, you know. So we can call this one K, and then we can call this one H. Make sure you indicated those things so that someone knows what you're talking about. At times it gets a bit nasty when you don't show these things. All right, guys, so let's just do the final thing here. This is the half. BE, remember it's 6 minus 3 is going to be plus 3. Ne? Yeah, it's a vertical line. Then here is going to be the same, 6 plus 3. You know that was the difference to get the distance. And then times K. K is going to be 6 units, so I made a mistake here. The height is going to be 6 units plus a half into 6 plus 3, also times 6 units. Ne. Okay, that's fine. And then, what is that? So this is 9. Okay, let's just do this one correctly. 0.5 into 9 times 6. What is that? It's 27. Yeah, this is the same thing. So just double that. It becomes 54 square units. Okay. Yeah, Bafeta. This one takes a bit of time. You can almost tell that, yeah, it's really chowing our time. All right, so how many marks were on offer here? 5. First of all, it is key to note this. It is key to find that. And then, correct substitution into some nice formula. So we've got that. And then we've got this one. So I don't know. Maybe finding the length of BE is yet another important mark. So you can get your 5 marks, but they're a bit scattered. So that's 5 marks. All right, guys, let's start with the money. What about the money? Now, question 6 says 12,000 rands was invested in a fund that paid interest at M% per annum. All right, compounded quarterly. So what is a quarter, guys, in a year? It's 3 months. So that's why the banks will ask you for a 3-month bank statement. It tells you exactly in a quarter of a year how you performed. So are you a risk for them to giving you what you are asking for, or any financial services provider? So let's have a look. Now it says after 24 months. 24 months is 2 years. So how many quarters are there in 24 months? There are 8, because each year has 4. Now it says the value of the investment has gone up from 12,000 to 13,459. Now the question is determine the value of M, which is that percentage there. Okay, let's deal with 6.1 right here. 6.1. Do we really need a timeline? I don't think so. So what we can do here, we know that A is equal to P, what am I doing? P into 1 plus I to the exponent n. And remember, in this equation, n represent years, okay? Just remember that. This implies that we were given here 13,459 is equal to, the principal was 12,000 into 1 plus, we can just say M percent over 4, because it's quarterly. Now for 2 years we have how many quarters? It's just basically, you can say 4 times 2, or you can just write straight up 8. It's really not necessary to to do a lot of complicated things. You can just put to the exponent 8. I won't ask you where you got it. It's correct. And then the least we can do now is to try and solve this thing. So when we solve this, we're going to have 1 plus m% over 4 to the exponent 8 is going to be equal to 13,459 over 12,000. Okay. Now when you get to this point here, you take inverse operations. So you take the 8th root. If you're trying to remove to the exponent 8, you take an 8th root. What you do to the one side, you do to the other side. So this implies that 1 plus m% over 4 is going to be whatever value we're getting there. So let's see. So we're taking the square root of that fraction, 13,459 divided by 12,000 is effectively 1,0590,48315. Okay, so just write everything as it appears on your calculator screen. This implies that m% over 4 is basically, you take 1 from that, okay, minus the 1, so we'll just get 0,059048315 essentially. Okay, may look a bit different, but remember, if you maintain those values, that's what you get. And eventually we can just simply say, I'm trying to see what this is, man. Now let's just conclude that m% h here is going to be equal to, now this, you cross multiply the 4 there, so you times whatever the answer you got by 4. Sorry, that's wrong. 0,059048315. I made a mistake. I said times 5, so I'm multiplying that by 4, and then that you times by 100 is going to be 23%, 62. Okay, so that's what I've got here. So that is what we have. But hey, let me check. Why do I think this is wrong? Let's just start over there. Square root of 13. Why is it such a high percentage? There's no bank that gives such a percentage. Not in your life will you see that. Those people want money from you, man. And then you subtract 1. You times that by 4. You win. And then you times that by 100. It's 23.62%. Wow, that's strange. Okay, let's see when we put that one back in there. So 23.62. Yeah. So we divide this one by 100. It gives us 0.2362. Yeah. You add 1 to that. And then we get an answer. And then we raise that answer to some exponent h. Yeah. And then we get what we get, and then we multiply this one by 12,000. And see if we're getting, this is wrong. Can't even again, don't go. What happened? Oh yeah, my mistake here. I didn't do inverse operations. I just took the square root. So that's why this answer is a little bit strange. I mean, I was wondering. I mean, I know this is hypothetical. It's possible, but always double check your answers because, yay, things happen here. So 1 plus m% over 4 is actually the 8th root. So I can see where my problems came from. I just took a square root. Okay, so guard against such things, folks. They will hurt even a very good plan. So this one is actually 1,014446,022. Okay, which when we solve this further, we can just simply say therefore, yeah, maybe not therefore as yet, just to try and show you the technique. So all we do, we transpose this and multiply by that. So you transpose that to that side and you multiply by 4. So you first minus 1, then we times by 4. So we're getting here 0,05. Say to 4 decimal places, 0,578. This is much easier, which is going to be equal to, therefore m there is basically what percentage, so you multiply that by 100, so it becomes 5,78%. Ne, Nazog. So you've got your answer there. So guys, I think we're losing time very quickly. So what is the story here? I mean, correct substitution into the correct formula, but I think this is also important. Doing your inverse operations there, and the answer is exactly how you get those 4 marks. We move on. 6.2. 6.2 says on January 31st of January 2022, Tino deposited $1,000. Okay, $1,000 in an account that paid interest at 7.5% per annum compounded monthly. So those are some of the most important things here. Now, if you're doing a deposit, it's like a savings account, so future value is in the cards here. He maintained depositing this 1,000 rands on the last day of every month, and he will make the last deposit on the 31st of December 2022. All right, so let's do our timeline here. Doesn't really have to be long. So T0, this is at the very beginning. Tino is putting that one, then T1, which is the next month, okay? The end of the next month, which is going to be 1,000 rands, one squatter there. And then, of course, this goes on and on and on and on. But the question is, what are these last two? Well, if you think about it, if you started at T0, remember there's going to be 12 terms basically. But the last one is just going to take 11. And then the second last is going to take 10. Yeah. These are some of the tricky parts. But if you understand what's going on, you can already decide to scrape T0. But for me, I want to capture the compounding period. So it's important to know that there will be 11, but when you calculate the total number of terms here, you're going to be having 11 plus this one, the payments in your formula. Okay, so let's do our information. So this is at 7.5% per annum monthly. So we are ready. So now the question says, will Tino have sufficient funds in the account on the 1st of January? So that is exactly the beginning of the month after the last payment, to buy a computer that costs 13,000 rands. Justify your answer by means of an appropriate calculation. For sure, we're using the future value here. It's going to be x into 1 plus I to the exponent n minus 1. All of that over I. Please guys, know these formulas by heart. You don't want to be wasting time checking the formula sheet. But of course, if you feel like you are not sure, or as a means of checking at the end of your exam, you may want to check. This one is nominal interest, so it's going to be 0.075 over 12 because we said monthly. But now what will be our n? N is this one minus the last one plus 1, so it's going to be 12. So minus 1 over 0.075 over 12. Of course, some things you just need to know off by heart a bit. And then you just do the calculation. The key with the calculation is making sure you are meticulous. It's easy to make errors here. 0.075 over 12 raised to the exponent 12 minus 1, close bracket. Then we open that, 0.075. So don't be quick like me, because sometimes I make these unnecessary mistakes in my calculations. And this hurts a lot. So what we're getting here, we're getting a value of 12,421.22 cents, okay, to 2 decimal places, because there was no statement that we have to round off to the nearest, so we basically do the standard general instructions. Okay, great. So the answer is, we're looking for 13 scored, but now we're getting 12 scored and 12.5 almost. Okay, so now if that is the case, I don't know if I wrote this correctly, yeah, but if you look at it, I mean, in reality, if you have this amount of money, go to those shops, they will actually sell you the computer. Because what is missing is just 500 some change, 500 some change. So they won't really let you go with the 12 scored or just because you are 500 short. They will actually just give you that discount of that amount of money and give you the computer. So in reality, yes, you actually have quite enough, but depending on how very industrious that businessman or person is. Otherwise, technically or in principle, you do not have him. And you can say, therefore, Tino will not have enough money for the computer price. Okay, I mean, you can write as much English as you want, it doesn't really matter. The key word is that he will not have enough money, that's all. So of course, how many marks were we getting here? 4 marks. Okay, so of course, correct substitution into the correct formula, you get a mark for that. You get a mark for the nominal interest or even the period. It depends on how they want to give you marks on this. And then your conclusion is important. Okay, 6.3. Let's quickly finish this financial math. Tabo plans to buy a car that costs 250 gorillas. He will pay a deposit of 15% and take the loan for the balance. Okay, the interest paid on the loan is 13% per annum compounded monthly. So we're using a present value formula. Now 6.3.1 says calculate the value of the loan. So 6.3.1, the value of the loan, not load, loan, is going to be equal to 250 gorillas. No, scotos. Why did I say gorillas? Thousands are what? Are the scotos. So this is 250 scoto. We're going to minus the 15%. So this is 15 over 100 times 250 scotos. Then we know that this is the amount of the loan that we're going to get. So we have 250,000 minus 15 over 100 times by 250 zlotys, but make sure your calculation is perfect, guys. So it's still a very high amount. It's not less than 200,000 even. So it's 212,500. It's still quite a lot, but I mean that difference is over 37,000. So 37,000, you're not gonna pick it up on the street. So it's quite a lot of money, but not enough to really make a big dent into this big debt you're going into. So this is the value of the loan. So they're giving you 1 mark, guys, because this is grade what? Grade 9 arithmetic. Yeah, this is what you would do in grade 9. So, okay. Now it says the first repayment will be 6 months after the loan has been granted. Okay. But the loan will be repaid over a period of 6 years after it has been granted. So there will be some months to lapse. Calculate the monthly installment. Okay, great stuff. So 6.3.2. We will answer it here. Let's just start here because it looks a bit technical. 6.3.2. Of course, we start with our number. What is this? Timeline. So we know that at T0, this is when we're taking the 250 zlotys. And then we have let's just say T5 here, up to T5, okay? Because we're not paying up until T6. T6 we start paying some X rands, which we don't know. And then we said this is going to go on up until 6 years. So 6 years basically is just 6 by 12, which is 72. Hey, where man? 12 times 6, yeah, 72. So this is T72. Again, we'll be paying our X amount, which is our last amount to be paid. So there we go. So what percentage was there is 13%. So this is a 13% per annum monthly, okay? Their time buffet is like a beast now. All right, so we know that we're going to use our present value calculation here, but remember, we will lapse for 5 months because the grace period, this is the grace period here. You can say this is the GP, grace period. So the grace period is when you're not going to be charged interest. It's always just 1 month, okay? So this other one is not a grace period, but sometimes when you bought cars, they would actually give you some grace period of 3 months. So you'll start paying after 3 months. This is when they don't really charge money as well, but normally grace period is just 1 month. So you're not going to consider interest, but we will have accumulated interest for 5 months. Then the loan will actually be much bigger than the loan would have been at this point. Actually, it's not 250,000 here. The balance of the loan is not 250, so I'm sorry for that. This is 212,500. That's what we took. Okay, so that's key. And then now we have to calculate the monthly installment. So we are ready here. So we know that our present formula is going to be X into 1 minus 1 plus I to the minus n, all that divide by I. Okay, so that's the basic formula for this. Then what do we do next? We know that this is no longer the same as that because there's a 5-month period that lapsed there. So we know that here we have here 212,500. Did we get 212,500? Yes. And then we know that this one technically accumulated some compound interest. So this is 0.013 over 12 times 5. The period is months, so it's going to be 5. is equal to this x amount which we are so interested in. So this is 1 plus 0,013 over 12, all to the exponent minus. Now remember, the time frame now is going to be 72 minus 5. Then that is 67. So to the minus 67 here. And then, of course, we close our little thingies there. We divide by this one, 0,013 over 12. Okay, so with all of this substitution, I will just simply rush to the final. So this implies, okay, you can say therefore x is going to be equal to, you take this and multiply this, so it's going to be 212,500 into 1 plus 0,013 over 12 to the 5 into this one, 0,013 over 12. Okay, I'm sorry for the cluttering there, it's just not in my control at this point. This is 1 plus 0,013 over 12 all to the minus 67. Okay, so we'll get our monthly installment in rands. So let's do this one. Complex calculation, 212,500 into 1 plus 0,013 over 12, all raised to the exponent 5 itself into 0,013 divided by 12. Okay. Divide that by 1 minus 1 plus 0,013. Don't know why here it likes to refuse to write, or maybe I'm too quick, or my calculator is growing old and it's such a good calculator. So please, calculator, don't grow old. Minus 67. Alright, so what am I getting, guys? This gives me a value of 3,307 rands 71 cents. Okay, so this is the amount this person must pay. It's quite reasonable, don't you think? So I'm sure it's correct, but do double check, guys, in case I'm making a mistake somewhere. Sometimes it's easy. Yeah, I made a big mistake. Big things. You see, big things are happening now. You see, this thing is not 0,013, so 13%. 13% is basically 0,13-ish. Yabona ke. Kimomathathe njalo. So there's no 0 there. Ish bafwethu. ASCII, I'm removing the wrong 0 now. So this thing does not exist, guys. A son. So this means this thing is wrong. Okay, guys, let's sort out the problems. So this is 0,13 there, 0,13. So there's no 0,0 there. All right, sorry. 212,500. Oops. 212,500. So time gets chowed in this thing. Yeah. It gets really chowed. Divide by 12. Raised to the exponent 5. Into 0,13 divided by 12. All of that 1 minus 1 plus 0,13. Ewan, why do you keep refusing when I get to this region? minus 67 and close bracket. Ha 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 ha. Now this one is a bit higher. Yeah, you can tell that the interest is much higher now, so I made it too small. So it's 4,724 rands 96 cents. Okay, so that's not too bad. Still less than 5 score though. So you can afford it if you want the car. Alright guys, so this is essentially the monthly installment that is needed, which is the X value. So this one is a bit technical, so that's why it's 5 marks. So you get a mark for this one, and then you get a mark for the entire general substitution, and you get a mark for this nominal interest. I mean, you can get it anywhere, so you can give it here, you can give it there, it's fine. You get 3 marks, and I think this one is mark worthy also. So you've got 1, 2, 3, 4, and then that is the 5th mark. Of course, I don't know exactly how they distribute those marks, so it's just an arbitrary guide. Okay guys, let's just try and squash this thing as quickly as we can. Question 7, differential calculus. 7.1, we are to determine the first derivative of this expression. Of course, using the power rule, you know this is 2x plus 1. So if we don't get that, we are dead. Okay, so we know that the first derivative in terms of the first principles, it is according to the limit when h tends to 0 of this particular expression, which is Newton's quotient, x plus h minus f of x plus h, like that. So you always copy that formula. Trust me, you don't do it, you are committing suicide, which is your own problem. So this is 2 into x plus h all squared plus, there is no 2. See, now I'm copying the wrong thing. So this is plus, there's no 2, man. We don't have a 2 here, plus here x plus h. So basically where you see x, you put x plus h, and then here minus the entire function all over h. So we're good. This is the limit as h tends to 0 of this thing. Now you FOIL it out, it's going to be x squared plus 2xh plus h squared plus x plus h minus x squared minus x over h. Now if you guys do the thing, if you don't get this happening, you know you are probably wrong somewhere. Okay, so double check and see if you're going wrong about anything. The only thing is that it's quite intense, but it's simple. So we've got 2xh plus h squared plus h all over h. Okay, so it doesn't have to be this long anymore. All right, so let's see the limit as h tends to 0. Now we take the highest common factor there, it's h into 2x plus h plus 1, okay, over h, and then of course these guys then finally do it after waiting for so long. Don't ask me what is that which they did. Okay, we don't really need to do this one. At this point, guys, I'm not going to be prolonging this any further. So here, we're just going to say 2x plus 0 plus 1, which is just 2x plus 1. So we knew that from our power rule. that is what we expected. So if we used the formula from the first principles, it still agrees. So we've got all the marks. I'm not going to try and show you where this comes from. So 7.2, we've got find the first derivative of this function f here. So here we're just going to use the power rule and not waste time. So you multiply, there's going to be 10x to the exponent 4. This is minus 12x cubed plus 8. That's it. So you get the marks for those three terms. Okay, easy 3 marks. And let's get to this one. Now we're told here that tangent 2g of x equals ax cubed plus 3x squared plus bx plus c has a minimum gradient at this point. Now remember, the minimum gradient of a curve, this one, the gradient of a curve is minimum only at the point of inflection, or at least that's the area of interest. We can forget about other possible areas, but that is the main area we want to focus on. So we know that the minimum gradient is at the point of inflection. So this is definitely the point of inflection, but can the tangent have a minimum gradient? The answer is no. A tangent only has its gradient. It cannot be minimum, it is just what it is, okay? So only the curve actually can have a minimum gradient. So I'm not happy with this word tangent to the curve has a minimum gradient, but we can say a tangent passes at, or a tangent to this curve here is at a point where the curve has a minimum gradient. I don't know if you think about it, and in fact I wish they would just scrape off this word tangent and say, look, I don't think it's significant. You can just say cancel out the word tangent. You can just say the graph of g, or you can just even say g of x equals has a minimum gradient at. That is what makes mathematical sense. Putting the word tangent is crazy. Do you even have a tangent in a cubic function? It's a bit of a situation, you know. Yeah, it's a bit of a situation, I'm telling you. But let's think about it. Now there's two possibilities. You know that our cubic function, we don't know what is the status of a. So our cubic function could actually be something like that. Origin there. It could be something like that. Or it could be something like this. With the origin there. So look, there are two possibilities because we don't know what is the characteristics of A. But we're going to use this information to our advantage. So what is the story? When do we get a minimum gradient? Remember, the point of inflection is the change of concavity. So since this is negative, so let's assume that our point of inflection, let's just use another color so that it's easy. Let's say our point of inflection is over there on the curve, is here. So this is where this point is -1 is to -7, okay? And then we can draw it here as well with another color if we want, and say perhaps it is here. So this is -1 is to -7, okay? So if we have our points of inflection drawn into our two possibilities, because for a cubic function these are the most likely possibilities. Well, there is a third option, but the third option is crazy. I don't want to go into it, so let's just forget about it at this point, because it's of a mother function. The mother function is not shifted around, so you don't get these terms. These terms effectively are not there, so you don't want to consider that, because this is already telling you this one is a shifted, so it will have this shape definitely. Okay guys, so when do you say minimum gradient? Now remember, at the point of inflection, if you draw a tangent exactly at that point of inflection, look at that. That is a negative gradient. So that is the smallest gradient this curve can take, meaning minimum. But if you drew this one over here, it would actually do something like that. Of course, don't worry that it intercepts. This is a local tangent. So I like the word when you're talking about tangents with respect to a curve like a cubic function. I think it's safer to say local tangent to a particular point, because as you produce that line further, it actually intersects the curve at another point, making it a secant instead of a tangent in general, but locally it is a tangent. So maybe let's use the word local tangent to try and be relevant. Anyway, so what do you do now? You can already tell that this is usually the maximum gradient, because this is a positive gradient. So that would be the greatest gradient this curve can take. So basically this one has a maximum. This one actually has a minimum gradient at the point of inflection, meaning we are looking at this one, and this one is out. Okay, so that is the story. So I don't know why there's 4 marks, but remember they said show any sketch, any diagram that you used to determine your answers. So basically you can rub this one off, because this talks about the maximum when a is less than 0. As you can see here, a here is greater than 0. The part that says a less than 0 is off, because it only gives us a maximum gradient at the point of inflection, but we are interested in the minimum gradient at the point of inflection. So I don't know guys, do you really have to say more? Once you've done this, you can say therefore g of x is going to be concave up such that x is greater than -1, because you know that after -1 this graph takes a positive concavity, and before -1 it takes a downward concavity. So we want a concave up. So I don't know guys how you're going to start phrasing this one, but this is part of the process. You can say, well, looking at the maximum gradient, you can say that for this curve to have a maximum gradient, it definitely means that maximum gradient at the point of inflection. Maybe let's do this. I know I'm chowing your time now, guys, so you will have to forgive the man. Well, we can say here, well, for G to have a minimum gradient at the point of inflection, because we can tell that should be the point of inflection, which is -1 is to -7. It is such that a is greater than 0. That's where you get your first mark, because when a is greater than 0, we get the minimum gradient at the point of inflection. And you get a mark for that sketch, because they said anything you have used to determine your answers, it is like that. And then once you show us what is going on, you get maybe 2 marks for that. I don't know. So this makes up the 4 marks. So it's good. All right guys, so let's just hold on. There's a knock. All right guys, I am back. So yes, we can sort this out in that manner. So you don't really have to find the equation of this graph. It doesn't really help at all, because you have enough information. If this is a minimum gradient, remember this is the derivative of a derivative, so this is the second derivative already, which gives us the point of inflection. So honestly, you can just think of what are the possibilities and what does the statement translate to, and therefore it gives you the shape of your cubic function. Of course, knowing very well that if you have these terms here, this is a shape like this. But if it was just ax cubed only, then it would be the parent graph or the mother graph, which is a bit different from these ones, because the point of inflection is also the turning point, or the turning points, so to speak. All right, guys, let's not waste time. This is how you score those marks, and let's move on to question 8. Question 8 is applications of calculus, or cubic function, so to speak. So let's try and race through this one. Question says the graph of y is equal to the first derivative. So the derivative here is in the standard form, mx squared plus nx plus k. So you see the variables there can be anything. All right, so it's drawn below. Now the graph passes through point P. Now once you see something like that, the zeros there, the zeros there, you already know that if y is 0, this is an x-intercept. If y is 0, this is an x-intercept. If x is 0, this is a y-intercept. Okay, so you can already tell those points right on the graph. So they are clear. 2, if we look at the shape of this graph, it is a grumpy face. So what does it tell us? It tells us that our m value here, m is less than 0. Because when m is less than 0, we get this grumpy face. So if we solve for m, we expect a negative answer. So if we get any other value, then that is probably positive, then is incorrect. Ne? Great stuff. Of course, k here is literally the y-intercept here. So k is exactly 1. So if you miss out anything here, at least find the value of k. You will be fine. All right. So what does that tell us? If m is less than 0, it means our a value, what did I do? Our a value, meaning in the parent graph, is also negative. Okay, I don't know why it's doing that. Maybe I didn't lock the screen. It keeps on doing its own things now. All right, guys, we don't want to overly interpret this thing otherwise, so we just work with it. So we've got the roots here of this first derivative, and we have its y-intercept, so we can actually calculate it using the root format. Now the question says determine the values of m, n, and k, so we can do them all at once. So 8.1, we know that the first derivative of x is given by, we can use the root form a into x minus the first root into x minus the second root. So this is much easier, which is a into x. The first root is a third, so minus a third is plus a third. Oops, not a half. Into x minus 1. That one is exactly like that, of course. Now we know that through that point r, which is 0 is to 1, because this is the point on the curve that we can use. So what do we do here? It will be such that 1 is equal to a into, oops, not x, but 0, plus a third, and 0 minus 1. So this implies that 1 is equal to basically minus a third of a, okay? Therefore, a is going to be minus 3, because you just divide by minus a third on both sides, you get that. So that is the story. Remember, this a is just this one here. It's not any other a. So this implies that the first derivative in terms of x is going to be minus 3 into x plus a third into x minus 1. Then we solve this as minus 3 into, when we solve here, it's going to be x squared minus x plus a third. It's going to be 2/3, so it's going to be minus 2 over 3x minus a third. Okay, that's what we have. So when you distribute that minus 3 inside, we get minus 3x squared plus 2x plus 1. Great, so now we can already tell here that we have our things there. You see, m is negative, it's a minus 3. Isn't it what we expected? And then it is. This one gives us our n value, which you cannot really predict at this point. Yes. And then we know that our k value there is minus 1. So this was m, this was n, this was k. So you can make a conclusion that therefore m is equal to minus 3, n is equal to 2, and k is 1. And then of course you get these marks straight up. How many marks were on offer? There's 6 marks. Okay, then finding this is the 4th mark. So wow. I think your correct substitution into some correct formula is cool. So it's 1 2 3 4 1 2 3 4 5. I don't know where is the 6th mark. Then maybe the correct substitution here. Yeah, I don't know. Correct substitution here again. But I mean, if you got a mark for a substitution, maybe that format can give you a mark as well, because it's something pretty important. So rather than to give you for correct substitutions twice, maybe we can give you for that format. It makes a bit of sense. So this is how you score those 6 marks. Okay. Next question, guys. It says determine the coordinates of the turning point. 8.2 says if it is given that f of x is, minus x cubed plus x squared plus x and then plus 2. Of course, this 2 you would not have known. It's not easy to know the 2, but the others you can really see that it's coming from exactly here. If you put this back, reverse power rule if you ask me, this is going to be minus x cubed, no, x to the 5. What am I doing? No, you reverse this, you put a 1, there's plus 1, so it's going to be minus x cubed into x squared, x cubed, so this is 1 here, this is going to be x squared plus x, and then of course the other 2 you would have to solve by using a point on the curve. So that's why they're giving it to us, because we were going to struggle to find this one because they didn't give us enough information which point is passing through the actual cubic function so that we can work out this guy over there. All right, not a problem, guys. We have sorted our things. So they're telling us the story that that is the equation of the cubic function. So it says determine the coordinates of the turning points of f. So this is easy. So this is 8.2.1. So this was 8.2. Bearing in mind f of x is minus x cubed plus x squared plus x plus 2. Ne? Hope I'm copying it correct. Yes, that is the one. And then we already know the x coordinates of the turning points. So we can say the x of, let's say, the turning points is such that the first x coordinate is minus a third and x2 is 1, isn't it? Because the x-intercepts of our parabola, which is the first derivative, are actually the x coordinates of the turning point. So now we can look for the corresponding y values. So we can say this implies that the y1 is going to be f at minus a third and y2 is going to be f at 1. Easy, ne? So this is a bit long, so you just put these things there. It's minus into minus into minus a third. Ne? Oh, no. Cubed. I when I'm on scanteen. Plus, so there we have x squared, so this is minus a third squared. I'm losing a bit of focus now, guys. The time thing is working on my nerves a little bit. Minus a third here plus 2. So what am I getting here is 49 over 27, okay? And y2 is basically going to be 1 there. So this is minus 1 plus 1, that's 0. So 1 plus 2 is 3. So this one you don't really need the calculator. It's a little bit less complicated. So we can say therefore the turning points are such that we have minus a third is to 49 over 27 and 1 is to 3. Ne. Easy. So how many marks were they given here? 3 marks. Wow. But of course these are important. I guess recognizing that those will effectively be the the x coordinates gives you the 3rd mark, which is cool. But remember, it's always advisable to show them in coordinate pairs. All right. Now the next question says, draw the graph of f. Indicate on your graph the coordinates of the turning points and the the intercepts with the x's. So this is 8.2.2. So we've got 8.2.2. Of course, here we need the x-intercepts because we already know the y-intercept is going to be just 2. The y-intercept here is always going to be 2. But we need the x-intercepts. So let's sort out first them. For x-intercept, it is such that put 0 there where y would be. It's going to be minus x cubed plus x squared plus x plus 2. That's the equation that we were given. And then, of course, what I'm going to do here, sometimes you want to test values, but I'm not interested in suffering. At this point, I just go to my mode. Then I go to option 5, which is equation, and then I go to option 4, which is a quadratic. So my a there is minus 1, my b is a 1, my c is a 1, and my d is a 2. Okay, so what I do, just keep pressing equal sign. It gives me that my x1 is a 2. So if I'm putting 2 here, I must get a 0. So this means that we can actually factorize this thing like that. Okay, maybe let's write this one properly. I don't like to write things in a skewed fashion. So this means minus x cubed plus x squared plus x plus 2 is equal to 0. Okay, which also implies that when we factorize this, we're going to have x minus 2 using the factor theorem. Into we try and get this one. So what we have here, if we already have a 2 there, we must have a 1. Again, minus 1. Because it's doing the things that must be done. So factorizing it by inspection. Then for us to get a minus x cubed, we must have a minus x squared here. Then we focus on this one. How will we get it? This becomes minus x. This becomes x. So this one must be actually minus x as well. Ne? So that we can say minus 2 times minus x, it becomes plus 2x. Plus 2x minus x is x. And we can see here this becomes plus 2x squared minus x squared. It becomes an x squared. And then everything else kind of works out. So we can say here, therefore, x is equal to 2, or minus x squared minus x. Okay, I don't know what is happening here. I don't know what is happening. So this tells us that our x is 2, or x is equal, why are you making me angry when I'm minus x squared minus x minus 1 is equal to 0. Now this you can already see, you can't factorize this thing. So what do we do here? To solve this, just check the discriminant. The discriminant is, if it is negative, then you know there's no roots there. So the discriminant is going to be minus 1, okay, squared, minus into 1, minus 1. So I'm getting a minus 1. So basically, this has no solutions. There's no solution here. Why? Because the discriminant is less than 1. So at some point, you don't want to stress yourself here. So always check the discriminant. I cannot overly emphasize that. I've shown you these things when I showed you question 1, paper 1, question 1 materials. I spoke about how you would check whether you can factorize a quadratic or not. If you do the discriminant, it will tell you. You get an irrational number, yeah, factorization may be difficult. If you get an irrational number, you get a non-real number, then it tells you there are no solutions at all. So there's only one solution there. This is a bit silly now. So this means all of this information must come down. SS. I didn't see that I copied everything down here. Okay, that's fine. Okay, so that is what we have to do there. Okay, let's see what is the story there. Then we know that, of course, for y-intercept, it implies that y is equal to 2. Of course, because x would be 0. So, okay, maybe we can say the x-intercept is 2 and 0 only. Then, therefore, the y-intercept is 0 and 2. We're moving a bit faster. So guys, we already have our turning points. We have our intercepts, so we can just go ahead and do the sketch. Origin. That's y. Okay. Now, the first intercept, we know that this is 1, 2. So this is 2 over there. That's 0. And then we got our y-intercept to be 2. So we're going to have 1, 2. And then one of these ones was 3. So we're going to have 1, 2, 3. Now, what do we know about our graph? We know that we have a third here. Minus a third. So when you're doing a sketch, you don't really have to worry too much about scale. Then we know that this third The third goes with 49 over 27. Let's see, what is that? That is effectively 1,8. So it's almost here. So it's almost there. So that's 1,8 right here. So papa wena man. 1,8 is over there. So maybe let's make it black, so that when we draw the curve it doesn't make a mess. So maybe let's use blue. And then we know the y-intercept is that one, and then when x was 1, we got another turning point at 3, so we got it there. And then this was another x-intercept. Then of course our a was less than 0, so our graph is doing things like this. Now we can't use the same color, just for trying to give you something. Doesn't really have to be too great, you know. You just do something that makes a bit of sense. Okay, that's the graph of f, guys. That is f. And then of course we have shown our intercepts there. Maybe I can now show them in black if I like. Well. So that is what happens right there. Okay, so what are we doing here? We just have to show that this is exactly coming from 1, so that's the turning point. And then this one is coming from that third and some 2 point. Maybe we can indicate this one as well, that this area right here is 49 over 27. We've shown everything, literally. So that's our graph. So you get a mark for the shape, you get a mark for that intercept, you get a mark for that turning point, you get another mark for that intercept, and then you get a mark for this turning point. So that is how you score those 5 marks. All right, guys, so this is sorted. So let's get to 8.3. 8.3 says points E and W are variable points on f prime, which is the first derivative, and are on the same horizontal line, meaning they are mirror images of one another if we're looking at a parabola, right? Because let's just, for argument's sakes, and say this, say E and W, ne? They said E and W, so let's say this is point E. And then of course if we do a horizontal line here, because it's not going to be perfect, then this should be W. So remember, if they're on the same horizontal line, meaning the y value is the same, so this means this is parallel to the x-axis. Ne, yeah. And they will definitely be equidistant from the axis of symmetry. You know, that's it. All right, so we have those 2 points. Then we're told here H is a tangent to F at E. Okay, let's do H. So H is a tangent. So the tangent will be drawn here. Okay, there is a tangent, which is H, they told us, at point E, of course. All right. And then we're told G is a tangent of F at W. So it doesn't matter, even if you put E this side and W that side, it would not matter. And then let's do this one, nice and easy. So this one is going to be cutting here. So it's going to go something like that. And then it's going to go down to wherever it wants to go. Okay. So that is the story. So we've got those two lines. All right, so we're told here that this is G. Okay, maybe let's use its color just for fun. Okay, that is G. All right, guys. Now we are told that H and G intersect at D. So we are told that this point of intersection of these two here is D, with coordinates A is to B. Okay, not a problem. So it says write down, write down the value of A. So what should A be? Like I said, if these two are on the same horizontal line, but they lie on the graph, these are mirror images, meaning they will be the same distance from the axis of symmetry. And effectively, this would become a perpendicular bisector of this line. So if you think about it, if we say this is the axis of symmetry right there, it should cut through the point of intersection of these 2 points. So we need to find what is the coordinate of the axis of symmetry, because this becomes a perpendicular bisector of this line, knowing very well that these points are going to be equidistant from the axis of symmetry. And effectively, if this becomes a perpendicular bisector of this line, it means these will intersect exactly at the same x coordinate. So these are some of the things you need to just think about, play them in your head. So effectively, A here is the x coordinate of the axis of symmetry, or the x coordinate of the turning point of that parabola. Alright, so they said write down. They didn't want any explanations, but I'm just going to show you a little bit of those explanations. So this is 8.3.1. So we know that A is going to be equal to, now when you're taking an average of these 2 points. So it's going to be x at P plus x at Q over 2. Of course, they didn't say show, but even if you show, you won't get extra marks. You just get 1 mark for the answer. So the x at P is minus a third plus 1. All of that divided by 2. So let's see what that is. So already this is 2/3 divided by 2, which is a third, okay? If you take 2/3 and you divide them by 2, you get each one as a third. So A is a third. So you can just write here, therefore A is 1/3. So this is very nice, man. Next question. So this is 8.3.2. Now this question says, determine the value or values of B for which H and G will no longer be tangents. Now remember, key here is that, look, if we put B here, for example, we put B there, what happens? Will we have tangents there? The answer is a hell no. So it means if B is this one value, these ones become seconds, isn't it? Or seconds. Some say seconds or seconds. Because now if you draw something that cuts there, let's say B is at the turning point, meaning the y value is there. So do you see G is no longer tangential to the curve, but it's actually cutting the curve at 2 points. So it becomes a second. Same goes for this one. If we said that this is the case, so we would have something like that as well. So do you see, we would have actually seconds if B was to be at that value and lower. So it is either this value or lower than that. So technically B, if it is here or lower, these ones become seconds to the graph. They no longer become tangents. But when B is greater than the y value at the turning point, we definitely can see that these ones will become tangents, but of different gradients. Okay, enough story. So the keyword is, let's find, this is our critical value here. If we find the y-coordinate of that turning point, we know that that is not allowed, and any value less than that. So let's see what values can we talk about. So we already can tell that, look, b should be less than or equal to the y-coordinate at the turning point. So we can say f dash a third. So which therefore we can conclude that b is less than or equal to I'm trying to think though. Is it also equal to? I'm not too sure about where, yeah, but I think if we say this is going there, yeah, they can't be tangents at that point. If they're on the same horizontal line, they will still cut the curve. Yeah, it makes a bit of sense. So f of a third. So let's see, what was the equation of f from above? So they're giving you a bit of a back and forth so that you can sweat a little bit. So this is our reference equation. So I substitute there with a third. So we get here minus 3 into minus a third, not minus a third, but into a third this time, all squared, plus 2 into a third, and then plus 1. So I'm getting 4 over 3. So this is good, this is good, this is good, this is 4 over 3. Okay, easy stuff. So I mean, you can use many formulas. You can use here y is equal to 4ac minus b squared over 4a. Try using that, you'll get the same value for the y coordinate at the turning point. Okay, that is easy, guys. So I mean, this is 2 marks. And then of course here they said determine. So if you determined, it's a bit fair to say this, and that is fine. Even if they said determine and they just wrote these two, you would still be pretty much allowed to do this. Yep. All right, guys. Hey, I'm tired. This thing is long. Anyway, let's finish up. So let's do question 9. Yo, these guys don't get tired, hey? Question 9 is given f of x is equal to x squared. So this is a basic parent parabola. So we have something like that, right? Because why is it smiling? A is greater than 0 because it's an invisible one. All right, so we will have here our x. That's y, that's the origin. And then we are told here, determine the minimum distance between points 10 is to 2. So if we say this is the point where x is 10, then we say that is the point where y is 2. So we know that this point right here is 10 is to 2. And then, a point on f. So a point on f can be any point. So if we say, for example, this one here is x, the corresponding is going to be x squared, isn't it? It's just going to be the function. So we want that distance between those 2 points. So what is it? That is what we want to find out. So that is the distance d. We want the minimum value for that. Okay. Now we go on and do our distance formula because we've got 2 points. So we know that d is going to be equal to the square root of, now we don't know the names of those points, so we can say x2 minus x1 all squared plus y2 minus y1 all squared. I finally used this thing. Okay. So let's see, if we choose this one to be x2, so it's going to be x minus 10 all squared plus x squared minus 2 all squared. Now let's check here. What do we end up with? So when you fold this out, it's going to be x squared minus 20x plus 100, okay? Plus this is going to be x to the exponent 4. And then this is going to be minus 2 is going to be 4, ne? Because this is 2x squared minus 2x squared is going to be minus 4x squared. Okay, and then what do we get here? It's going to be plus 4. Okay, great. So let's just organize these in ascending exponents. So in the order of their powers, so this is exponent 4, then x squared minus 4x squared is minus 3x squared minus 20x, and then 100 plus 4 is plus 104. Okay, now the question is, can this be factorized? Maybe such that we can find a way of removing the square root sign using exponential rules. Well, there's a way of checking. I kind of forgot, so I will remember at some point and show it to you guys later. So let's just continue here. So here this implies that d is this, and then of course we know that we can do inverse operations when we don't have any better idea. So what will this imply? It implies that d squared is going to be effectively x to the exponent 4 minus 3x squared minus 20x plus 104. Okay. Now we can say now for minimum distance squared. Oh, my squared is wrong. It is such that the first derivative of this squared is equal to 0, ne? Now let's see here. This implies, now we take the derivative of this thing. The derivative here is going to be 4x cubed minus 6x minus 20 is equal to 0. Now the question is this factorizable? So if you have a fancy calculator like mine, you just go to mode, go to option 5 equation, and then you go to option 4, which is the cubic function. You just put those coefficients and you just keep moving, because you don't want to struggle, my friend. So you just solve here. All right. Is there something strange here? Something looks a bit strange. Something looks a bit strange. Why am I not getting solutions? This thing says I cannot factorize this thing. Now I'm trying to figure out what may have gone wrong. What may have gone wrong now here? Why am I not getting my answers? Ewen, what is that? So I'm getting very strange answers here. I don't know, man. Is there something wrong with this? Okay, so let's see again. Power rule is going to be 4x cubed minus 6x minus 20 is equal to 0. And then we simply solve for x here. I'm trying to see what is going on here. 4 into, let's say, we're going to put, say, -1, but -1 won't work already. Say -2. So -2 into, that cubed, -6 into -2 squared. Not squared, but -2. Then -20, I'm getting -40. So what happens when we put a +2? I'm getting 0. So I don't know what happened. Maybe I punched some things wrong. So when we put a 2 in here, we get 0. So meaning, using factor theorem, if we put a 2, then it means x minus 2 was a factor. And then we go on. Then we say here, what do we have? It's going to be 4x squared, right? To get 20 when we have 2, it must be 10. But now 10 must be positive if that is already negative. Now let's sort out the middle term. We want to get 6, so we already have 10x. Then it's going to be, for us to get a 6, we must get a -16x. So this must be a plus. Now this is going to be 2 by 8x, okay? So this gives us -16x plus 10x, which is -6. So that's good. So we can say here, therefore, here our x is equal to 2, or 4x squared plus 8x plus 10 is equal to 0. Now, check the discriminant there and see if it is a rational, it's a perfect square, if you can factorize or not. So our discriminant here is going to be 8 squared minus 4 into 4 into 10. So the discriminant is -96. So if it is a negative, therefore you can't have a negative under the square root sign. So here you'll just say no solution. Okay, because the discriminant is negative, meaning the roots are non-real for this one. So it's as if I knew this was going to be something like that. So anyone who really paid attention to the channel and subscribed and saw all the videos that I posted and actually watched them. Some are very tiring and long. Sometimes it's very difficult to see because of the resolution of that camera. So you may feel like you're being bugged, but you were being bugged for the good things, because these kind of things will save you from unnecessary strain. Then we know that x must be 2. So we can go back and say, fine, when x is 2, we want the minimum distance. And the minimum distance is basically this one here. So you can just put this one and solve. So it's easy. So you just take this and substitute into the distance equation, because you don't really need this one. The distance squared, you'll have to square it again. So you can say, therefore, the minimum distance is going to be equal to the square root of, we got x as 2, but to the exponent 4. And then what else did we get? So we got -3x squared. So this is -3 into 2 squared. The next one is -20 into 2 plus 104. Okay, so this is going to be your answer, guys. So they didn't say much about it. So the square root of 2 to the exponent 4 minus 3 into the exponent 2. 3 into 2 squared minus 20 into 2 plus 104. What is that answer? So I'm getting 2√17 units. Okay, so this is good. it saves you a bit of a problem, because I mean, the good thing is that you solved for the value of x. So if you solved for the value of x, you don't have to worry about substituting here and then doing again square root signs. You just go straight there, because all you were interested in is the value of x anyway in the first place. So it solves your pain somewhat. Okay, so this was an 8-mark question. So how were these 8 marks arrived at? Yes, correct substitution. Ne? Eventually doing inverse operations here, and I think for minimum distance squared, you have to explain that this is squared. This is a key statement, and doing the actual derivative is key. So we have already how many marks? 1, 2, 3, 4. And then factorizing this thing, we get a 5th mark, and then we get a mark there, 6th mark. So 1, 2, 3, 4, 5, 6. Okay, and then we have 6 marks, right? And then here, correct substitution, and the answer there are your 8 marks. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, not a big deal, easy stuff, but a bit silly. The question is a bit intense. Okay, not a problem, guys. So let's solve this problem. So now we're going to question 10. So let's finish this as quickly as possible. Question 10 says A, B, and C are 3 events. Okay, the probabilities of these events or any combination of them occurring is given in the Venn diagram. So now these are already put in probabilities. So we only don't know 2 things. We don't know y, we don't know x. So those are the things to determine. Now we are told here, if it is given that the probability that at least one of the events will occur is this one, remember that is the complement of none of them having happened. So meaning y, the complement of this is y. And exactly what is this probability? Is the probability of the whole circle of A plus the probability of the whole circle of C plus the probability of the whole circle of B, of C, yeah? C and B. Yeah. So this is what it gives us. So literally when we say none of them, it's going to be y. Now the question says y, the probability. Okay, calculate the value of y, the probability that none of them will occur. So that is its complement. So we can start here, 10.1.1. A. We know that y is y minus this 0.893. So just go for it. Don't be explaining things and writing unnecessary formulas. 1 minus 0.893 is giving us 0.107. So that's it. Sorted. So it's only 1 mark, so you don't want to complicate things, but just remember y is basically the complement of at least one of them occurring. These are complementary events. The next one says x, the probability that all 3 events will occur. Now if we're saying all 3, it means when we add up all these probabilities, they must give us 1. So let's start 0.05 plus 0.015. So maybe let's do B here. So we're going to have 0.05 plus 0.0, not 0.0, but 0.15. Eh? Yeah. So the only thing that this is doing is really nasty. So we're going to ask ourselves, this is going to be 0.1 plus x plus, so I've done these ones on A. Now let's go for B plus 0.183 plus we have a 0.2 there plus Of course, we've already added this, then we're adding this 2 plus that 0,05 must be equal to 1. So this is terrible. So some digits can go missing here. It's very easy. So this tells us that therefore x is going to be 1 minus the sum of those things. So we can say 1 minus 0,05 plus 0,15 plus 0,1 plus 0,183 plus 0,2. So please guys pay attention here. It's easy to make mistakes here. This thing can really hurt. It can really hurt. So now what are we getting here? Maybe let's just first add these ones together. Something looks a bit strange-ish. Did I miss something? Oh yeah, there's one thing we forgot. We forgot something. We forgot the none of them, so we didn't add that one here. So we cannot rush. So plus, we need to add that one. It's 1, so it's 0,107 is equal to 1. Therefore, x is going to be equal to 1 minus the sum of these things. So basically, we're starting again. So 0,05 plus 0,15 plus 0,1 plus 0,183 plus 0,2 plus 0,05 plus 0,107. So that is 0,84. So we just take it from 1, so we get 0,16. Okay, this is a bit silly for just 1 mark. I mean, maybe 2 marks would have been fair here. But that's what it is, you're getting this one. So let's see. Now we're told here, determine the probability that at least 2 of the events take place. So what are we looking for, guys? The intersections. So if we're saying at least 2 events, so we're looking for the intersections. It's going to be this one, and that one. So it's 2, 2, 2, or 3. So remember, at least is greater or equal to 2. So meaning it can be 2, can be 3. So it's all the intersections basically. So we can just say here 8, 1, 2. What are we going to say here? We're just going to say the probability of the event. We know that it's at least 2 of them. It's going to be all the intersections. So it's 0,16 plus 0,15 plus 0,1 plus 0,2. Yeah? All these intersections here. So we have 0,1 plus 0,16 plus 0,2 plus 0,15. So this one is 0,61. So this is equal to 0,61. So just double check if you wrote everything correctly. 0,15 plus 0,1 plus 0,2. Yeah, I'm getting 0,61. So that should be the answer. So they're giving us 2 marks this time around. So that substitution and the answer gives you 2 marks. Okay. You see now. So this is where this thing should be. And then this one ceases to exist. So I hope I've answered all these questions. Okay, so the question says, are events B and C independent? Justify your answer. So first we can say the probability of B and C is going to be the intersection between B and C. And what is that intersection? Between B and C, 0, 2 plus 0, 16. So that is the intersection between these two circles. 16 and 0, 2. So we start there. So this is 0, 16 plus 0, 2. Which we know that this is going to be 0, 36. All right. So we can say, but what? We know that P of B multiplied by P of C is going to be, now it's going to be all the stuff that appears in B. So the probabilities for B here is going to be all of the 0, 183 plus 0, 1 plus 0, 16 plus 0, 2. These are all probabilities for B. And this is 0, 643. Multiplied by all the ones for C. It's all these that appear inside that circle C. So this is 0, 16 plus 0, 15 plus 0, 2 plus 0, 05. So this one is 0, 56. Okay. And then let's just do this one. Then we multiply this by 0, 643. Okay, what I'm getting, guys, is 0, 36 to 2 decimal places, which is equal to P of B and C. And therefore, if the product of these two probabilities is the same as the intersection, we can say, therefore, events B and C are independent. Okay. So that is sorted. Easy stuff. So you just needed a few steps to think about. So getting this probability and effectively calculating these probabilities, I think, is important, because they were not there, 3 marks and then 4 and then your conclusion 5. Okay, done. Okay guys, let's get to the last question. I'm tired. It looks like my questions are finished. What is that? What was that? So I don't know what is happening. Oh, this one jumped. This was supposed to be below this one. Okay, now let's do 10.2 quickly. So we have 10.2.1. Okay, now we are told here 4-digit code is required to open a combination lock. Okay, the code must be even numbered. I don't know, why do they say even numbered? Because this does not make any mathematical sense. But if you're saying it's an even number, okay, if you're saying it's an even number, it makes sense, because now you start to think, is it containing only even numbers, or is it itself an even number? So we don't really have any sensible term put like that, even numbered. So these guys are trying too hard, they're trying too hard to put, some tricks there, but these tricks are really not correct sometimes. I wish Umalusi can do the right thing here. Do the proper moderation of these papers. They don't moderate these papers. That's what it means. There was a mistake on paper 2, which was allowed to go into the exams itself. who moderated that paper? And what exactly is that person's knowledge of mathematics? I'm too critical because this is a national thing. It's of national importance. So we cannot really have such problems occurring and nobody sees them, when this thing is already something that is supposed to be checked and checked and checked, and of course for correctness, checked for appropriateness, checked for relevance to the curriculum and how it is taught in the country. And of course, these people themselves have to test themselves in these kinds of questions so that they can see whether a matric student can actually handle this or not. But hey, that's fine. So all we're going to say, we're going to stick that this is an even number because it doesn't make any sense. If we missed it, it's fine. Just going to miss 8 marks, which is not too bad if you've been, meticulous elsewhere. All right, so it says this may not contain the digits 0 and 1. So what does that mean? Therefore, strongly, our asterisk there is correct because it means this is an even number. Because if we said it's only containing even numbers, we would only say 0, 2, 4, 6, and 8. Now, if it is not the case, if we're eliminating 0 and 1, that's a clue that this must be an even number. The other thing that can help is if you guys have papers that are written both in a vernacular, close-up, for example, and English, then you would just look on the closer side and understand what is going on. I don't know if you would understand the closer in maths because we never really were taught maths in closer, so I don't know. But the other thing is if you are an African speaking, you would see the African side and see if it makes sense in the English side and then combine the two. But then if you're just speaking English, you may run into a few problems. So I don't know how you're going to survive this. But anyway, read the whole statement. Sometimes it provides a bit of clues as to what this crazy statement is. As controversial as it is, this makes up for the mess. But I feel like controversial statements must be kept out of the exams. This is not a discussion in the office. This is a matter of, a career determination or determining exams. So there mustn't be controversial stuff put in. We need to mean what we say. And then, of course, it says digits may not be repeated. So those are strict rules in how we deal with this one. So it says, how many possible 4-digit combinations are there to open this lock? Okay, think about this lock being just, a password, or an access into a systems of a computer. You have a number of bank consultants. They have to log on into that system for each customer that they have to assess or deal with. And each one has a unique PIN, but this PIN has certain constraints. It opens the same system, but for different people. So think about this lock not necessarily being a physical lock, but perhaps a lock that has maybe a computer of, how do you access a particular system? So this is something like that. Because to say a lock, it makes it a bit silly. A lock can only have one combination. It can't have multiple combinations, you see? So this is why these kinds of questions are poorly designed in that, they're trying too hard to make tricks, but if you read these statements and you try to see the practicability of this, it's just absolutely ridiculous. But I'm not going to say too much because I'm not perfect myself. But remember, this is national importance. Me is just a hobby to teach you guys. So I don't have to really be responsible for anything because I told you I'm not a teacher. So you better be careful of the things you learn from me. But I can assure you that you will learn a lot more than you probably would be expecting of someone who is not a teacher. But nonetheless, you need to maintain your vigilance because I may say things that are outdated, probably things that are cancelled out of your curriculum, or things that are perhaps flagged as not acceptable. So that's why you have to maintain that vigilance. But people who are employed to make sure these papers, can make sense. How will you explain this to a student when it's like this? A lock has multiple combinations. Is there such a thing? I don't know. I've never seen one, but if I think of a computer lock, which is not a physical lock, but it's sort of like an abstract lock. Yes, you can have a situation like that. Anyway, guys, let's just stop nonsense here. Now, there's two things to consider here. First, what if we have an even start? Because there's a lot of digits. Remember, digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we're saying this should be even. But this even number is saying these two are out. We don't want them. So we have how many even numbers here? 1, 2, 3, 4. How many odd numbers do we have here? We have 1, 2, 3, 4. So we have a total of 8 numbers to work with. So now let's say in the first instance, if we have an even, I'll just say even start. This will be such that we have 1, 2, 3, 4. So if we put for the first one an even number, how many of them in total do we have? 4. Then if we put 1 in there, remember at the end we must have an even number. So we've already put 1, there will be 3 left for this one. Then if we put 2 numbers down, how many do we have for this one? Remember we had 8, so we took 2, that's 6, that will be 5, okay? So just multiply those possibilities. So how many possible digits will we have in that case? So it's going to be 4 times 6 times 5 times 3. So we get 360. This is just the possibilities. And then of course we do another thing. We say we have an odd start. I mean, you don't have to say it my way, but you can say it your way. 1, 2, 3, 4. How many odd numbers do we have? 1, 2, 3, 4. So if we're starting with an odd number, we've got 4 options. For even numbers, because the end must be an even number. So we've got 4 options there. So if we take down 2, we'll have 6 left. So there's going to be 6 here. And then there's going to be 5 options there. So again, we just do those possibilities. Again, this is slightly different. It's 4 times 6 times 5 times 4. So this is 480. And therefore, we know that therefore the total is going to be 360 plus 480, which is going to be 840 possible 4-digit codes. So we have a total number like that. So if you guys watched my video when I did probabilities, specifically probabilities, I think there's a video where I did the May-June 2021. I don't know if I combined it with 2018 or something, but there's a combination of things there. You will learn that actually you could split these into even and odd starts when you have a controversial situation like that. And then at the end, you just simply add those possibilities, because that's the total possibilities you would have. Or you actually even decide if you're going to start with this one and start with that 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 one and start with that, start with that and that. Then you can have a long thing, but eventually it should give you this. If it doesn't, there must be a mistake either by me or you. Okay, not a problem. Okay, guys, let's just finish this thing now. Getting out of hand. So we've got here 10.2.2. Let's finish this. Now this says calculate the probability that you will open the log at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. This one. Further restrictions. But remember, what is the umbrella statement is that opening statement. And that opening statement is translated into question 10.2.1. So the total number of possibilities in this instance that is given is going to be the total of 10.2.1. But then we're putting further restrictions. So that means the probability will be the number of ways that you could get a digit like this in 10.2.2 over the total number of possible digits because of our umbrella statement over there. So be careful of these kinds of questions. They will work on you. First of all, we want the total number of ways in which this digit can be done. So we can say the number of ways or number of codes that we can get is going to be such that we have 1, 2, okay. First of all, let's think about it for a second. It's going to be the same scenario, right? So even start such that we have 1, 2, 3, 4. Okay, so if we have an even number, but remember now the restriction is that it has to be 5,000. So this means this start can only be 5 to 9. It can't be 4 because that would be a number less than 5,000. So the start is from 5 and more. But remember, we have odd numbers together with even numbers. So if we have an even start, the start is now strictly 2 even numbers. If we're starting with an even number, so we've got 2 possibilities here. Now, remember, the last one captures all the even numbers in that constraint that we were given. So how many do we have left? We had only 1, 2, 3, 4 in total. So we took 1 out. So we'll have 3 even numbers left to put in that. No, not 3. Sorry, guys. Remember, the third digit is a 2. So a 2 is only one option, and that 2 is an even number. So we only have 2 here left, okay? Because there are 4 in general. And then of course, if, yeah, this question is hard, it's not easy. Now remember, we've taken one even number, and then we've taken one even number and another, so we're left with just how many numbers? Just look at the total. We've taken down 3 numbers out of 8, so there are 5 here. So this is going to be something like that. So it's going to be 2 times 5 times 1 times 2. Yay, when? What am I saying? Wait a minute. Wait a minute. What is the story here? This question is tough. Don't take it lightly. Okay, let's try to figure out what is going on here. So this is 5,000. So we're going to start at 5 and 9. So we can start with any of these numbers from 5 to 9. But these numbers are in 2 groups, even numbers and odd numbers. So if we say it's an even start, so for here, we only have 2 options, which is numbers greater than 5. So it's going to be 6 and 8. So there's 2 options here. Then they told us that this one is a 2. The third digit is a 2. So we only have 1, 2 in there. So it's going to be one option. Then remember, we've taken out now 2 even numbers. In total, there were 4. So there will be 2 left to put in that state. Ne? Then how many numbers have we put down? 1, 2, 3. So we had 8 numbers in general or in total. So how many options do we have there? Out of 8 minus this 3, we've got 5. So yeah. So this is going to be 2 times 5 times 1 times 2. Hey, yane. Kemwitaba. This is 20. This is shoo. And then we've got our second option. What if we have an odd start? But be careful with these questions. You can go wrong easily. 1, 2, 3, 4. Because we're multiplying these. So how many odd numbers in this case? We can take 5, we can take 7, we can take 9. So there's 3 options for the first digit here. So we've got 3 options. And then what else can we do? The next thing we can do, we know that there's only one option for the third digit. It is a 2. So now we had 4 even numbers. So this has to be an even number. So we've taken one even number. So we're going to have 3. And then how many do we have for this one? Again, we've taken 3 numbers out of 8. So there's 5 options for that. And then we simply multiply those options. So it's 3 times 5 times 1 times 3, which is 45. And therefore, what is the total number of digits that fit this mess? Is going to be equal to 20 plus 45. This gives us 20 plus 45, that's 65 different, or let's just say possible, let's just not say different, say possible 4-digit codes that match that restriction. Ne? Hey son, I ran out of space. Is that even real? Okay, let's do this one and add some space in here. So, well, this implies, therefore, we can say, therefore, the probability of the event occurring is the number of ways that we can express this event, which is this code, is going to be 65 over the total number. We've got 840. Okay, 65 divided by 840 is basically 13 over 168. So I'm going to leave it at this one, 13 over 168. This is the answer. Of course, the first attempt, remember, is the possibility, the first general probability in this pool. It is going to be 65 codes over a total of 840. So this is the probability. And this would be the first attempt, because if you guess any of these 65 codes, basically, you can guess any one of them the first time around, you will be cracking that lock. But if you're guessing it for the second time, you just say this to the exponent 2. If you're going 3 times, to the exponent 3, and so forth. So these are some of the tough questions, guys, which, yay, they will work on your nerves a bit. So let's look at this one. 5 marks. Okay. So, of course, you're getting a mark for that, and then you're getting a mark for the total. Ne? So that's 3 marks already, and then, of course, correct substitution and the final answer. This you can leave it as a ratio like that, or a fraction, or you can leave it as a decimal, or you can leave it as a percentage. But I will assume there I have a bit of a problem with the last question, because the way it is phrased is a bit strange. So I would maybe put a bit of caution for someone on this one. I could be completely wrong, but I'm confident in the approach. If it is correct, then definitely getting maximum marks. If it is incorrect, then you're getting 0. Alright guys, that's the end. I hope you enjoyed the ride. And if you are not convinced already, I don't know what will convince you to subscribing, because you will definitely learn a lot here to improve your marks. You may actually walk away with a distinction at the end of the year if you work with me, but I am not the sole mathematics and physical science tutor you can find on this platform. In fact, there are even better ones than me. So you will already find a whole lot of them. A good friend of mine, Mr. Chauke, is Emmanuel Chauke. He has a channel that you can look into. He's done a number on some sections of this paper, so you can learn from him some different techniques if there's something he's done differently there. I didn't watch all of them, but I've watched, most of them I have watched. So in fact, I may have watched all the videos on this paper. So please do have a look at that guy. He is very good. In fact, he's a mathematician, so he knows even maths beyond metric levels. So if you stick with that guy, you will learn even beyond metric. And then there's MV Tutors, very good guys as well. You can learn there. They do maths and physics. So what am I saying? There's plenty of people. The virtual tutor guys takes you from grade 10 to grade 12 for maths and physics. So you learn there a lot with your siblings if they're following you just after you, or just behind you. Then you can have So there's plenty, man. What am I doing? Because naming them is not going to be fair because there's too many. There's lady NTE. That lady is brilliant. She does grade 12 stuff strictly. So maths and physics, you will learn there enough to really score a distinction. There's Levi. He does maths only for grade 12 strictly. So there you may actually see a whole lot of, similar approaches and sometimes different approaches. So, I mean, you can learn. So there's plenty of people, guys. To name these guys is really unfair. So, because the ones that you don't seem to mention, it seems as if you're not really appreciating their good work. I mean, there's giants like Mlungi Sinkosi, giants like Kevin Math and Science. There's giants like Mr. Amin, or Maths with Amin. So there's plenty. So others they keep on showing up now. Others have already been there. So there's still more to come. Anyway, guys, good luck. I hope you can see how you could have done this paper. And if you are a grade 12 for this year, then you can see what you're going into. So you better start pulling up the socks. Otherwise, goodbye for now. See you in the next video.